This course uses a range of third-party testing tools. Some are commercial products and some are open source. This course focuses on defensive rather than offensive tools, and we have done our best to ensure that the tools we use and the sites we reference are legitimate. Nevertheless, testing sites can be targets for hackers, and we can't provide any assurance that these sites might not be compromised when you visit them. Some of the sites which store the testing tools are detected as hosting malware and may raise alerts when you visit them. The testing tools we use to demonstrate the capabilities of the defensive tools are extremely powerful. They may demonstrate some of the same signature characteristics as malware and malicious implants, and may raise antivirus alerts when you try to download them. Again, we can't provide assurance that the software hasn't been compromised when you download it, and so, as for any other software from the internet, you need to exercise due diligence and take personal responsibility for anything you load into your own system. Kali Purple is a modified Debian distribution of Linux, which is designed for cyber defense. It's the defense equivalent of the Kali Linux penetration testing platform. In this course, we'll look at how to establish a virtual network of systems to use as a cybersecurity test lab, how to use the Kali Purple system itself, and we'll check out some of the tools provided by Kali Purple for cyber defense. I'm Malcolm Shaw, and I've spent a career helping government and businesses protect their systems. I'd like to invite you to take this course and learn how to use Kali Purple as your own learning lab. This is a practical course and introduces you via Kali Purple to the major open source solutions used in cyber defense. During this course, I'll be using a virtualization environment called Proxmox and a set of testing platforms and tools known collectively as Kali Purple. You don't need any prior knowledge to take this course, as I'll provide an explanation of each of the tools as we go. I will, however, assume that you have some basic computer knowledge, can understand the basic commands used in the Linux operating system, and are familiar with common networking terminology. Before we start using Proxmox, let's check out its interface. The top entry in the left-hand tree menu is the data center. This is the overall view of the resources that we have allocated to this instance of Proxmox. In our case, we're running on just a single node, so we have just Cybex shown as an expansion of the data center. It has a green tick, which means it's online. We could have more nodes running in the data center to increase the available resources that we can use, and these can all be accessed using this console screen. I have a home data center running, which has 4 nodes clustered into the one data center, all active. And at the lower right, we can see we have 9 VMs running and 28 VMs created, but currently stopped. Okay, let's get back to our course data center. When we expand our Cybex node, we can see the compute and storage resources running on that node. Currently we just have the network and storage devices, but we'll see virtual machines and machine templates appear here as we proceed. Let's go back to the data center. At the top left we have a drop-down which provides different views in the left-hand panel. We're currently in the server view. This details the virtual machines and the disk storage per node. If we check the drop-down, we can see that it provides 3 views of our data center: server view, where we are, and an additional folder and pool view. We don't have much in the way of resources set up yet, but we'll be working from the server view in this course. However, let's take a quick look at the other 2. The folder view shows the resources listed as nodes, software-defined networking, and storage. Expanding nodes, we see our Cybex node. When we expand SDN, we have our default network. Storage shows the same 2 data stores as we saw in our server view. The pool view lists the virtual machines that we've set up, but we don't have any as yet. Okay, let's go back to the server view now. The middle panel is the main menu for the resource that we've selected at the left. We're currently on Search, and this provides a summary of the data center resources and their usage. If we move down to Summary, we get the status screen we saw previously in our home data center. And when we scroll down, we get a dashboard of CPU, memory, and storage usage. We can see we're not doing a great deal on the data center at the moment. The Notes option allows us to add notes for our own use against the data center as a whole. We won't go through the rest of the entries here, but as you can see, there's quite a lot to learn about Proxmox. Let's select our Cybex node now. We now have the node context menu in the middle panel. We can see at the top right that we have options for rebooting the node, shutting it down, getting a command shell to work at the hypervisor level within the node, and what are called bulk actions, which we can take against all virtual machines on the node, specifically starting and stopping them. Above these options, we also have a link to the Proxmox documentation held on the node itself. This includes administrative guides and other resources that we might want to use. An important button we'll be using shortly is Create VM, which is how we create a virtual machine on the node. Create CT allows us to create Linux containers and then run container-based services rather than full virtual machines. We won't be using containers in this course. The far right drop-down provides access to our account settings. Back in the middle panel, we can select Summary. This is the main node screen we use when we're running our virtual machines. It provides a dashboard of the resource usage for the node, together with node performance graphs as we scroll down. At the right-hand side, we have some hardware details. We can see we're running 31.23, about 32 gigabits of memory, and we have 8 CPUs available. If we select Disks in the middle panel, we can see the physical disks in the node. Here we see we have 2 solid-state disks, a 512 gigabyte disk called Dev NVMe ON1 and a 256 gigabyte disk called Dev SDA. Okay, that's a short tour of Proxmox, but sufficient for what we need for our course. If you want to learn more about using Proxmox as a home or business data center, check out Scott Simpson's Proxmox course in the LinkedIn Learning Library. Let's build a Proxmox penetration testing lab. The first thing to do when setting up our lab is to install an operational Proxmox node into which we can load virtual machines. To do that, we need to have the Proxmox installer available as a bootable system on a USB stick. Let's download a Proxmox image from the website shown here. We'll download the Proxmox VE version 8 ISO installer. Once we have that, the next thing we need to do is to burn it as a bootable image onto a USB stick. We can do that with the Rufus tool, which we can download from the site shown here. I have that downloaded already, so let's go burn. We have a USB stick ready to be set up. We'll select the correct drive from the drop-down at the top, checking very carefully that it is in fact our USB device. We can then click Select and navigate to our Proxmox image that we've downloaded. We'll make a small change to the volume label, PVE 8. And we'll leave everything else at default, and then click Start to start our burn. We'll select the DD image mode and confirm that we want to start. We can now leave this to complete the burn, and we'll have a USB stick, which is a bootable installer for Proxmox. As we noted previously, Proxmox is a native hypervisor, and it will overwrite any existing operating system and files when you install it. Make sure whatever hardware you use has nothing of value on it before you run the installation. To install Proxmox, we connect a keyboard and monitor to the NUC. Insert the bootable USB installer into the NUC and turn on the power. We then hold down the boot menu function key. This is specific to the type of NUC, but it's normally F7 for Intel NUCs, although for the Skull Canyon we can use F10. We should then see the Proxmox startup screen on the monitor, and we can select the first option, which is to install Proxmox VE Graphical. The installation is very simple with just a few questions to answer. As this is done via the NUC console, we can't show it directly, but the steps we take are as follows. We agree to the terms and conditions, and we're asked to select the disk onto which Proxmox should be installed. There's usually just one SSD in the NUC, so we accept the default. We then enter our location and select the keyboard layout. Proxmox then asks for a password for the root account, and we enter and confirm that, and then enter our system administration email address. We then enter the details for the node, including a fully qualified name, for example, cybex.com, and we enter the IP address for the node. After that, we start the installation, which runs to completion, and then the NUC reboots. At that point, we can connect the NUC to our router using an Ethernet cable and access the Proxmox management screen on port 806. The Proxmox system we'll be using is on IP address 192.168.120, so we can browse to HTTPS 192.168.120.8006. And we can select Advanced and proceed to 128.168.120. We select Root as our username, and we'll enter the password that we put in when we set it up. And we'll press OK, and we're at the main Proxmox portal. Let's install a Kali Purple workstation with its collection of defensive tools. The Kali Purple ISO is available from the OffSec website, shown here. I've already downloaded this to my host PC and uploaded it into Proxmox. The installation is very similar to installing Kali Linux. We click on Create VM, and here we can set the VM number. We'll use 101, and we'll just call it Purple. For the OS, we'll pick up the Kali Purple ISO that I've uploaded. Again, we don't need to change the type, it's a Linux. We'll click QEMU Agent. We're fine with 32 gigs, and we'll use 1 core and 2048 megabytes of memory. And we're fine with the network, confirm, and we'll start after created. And finish. Okay, the virtual machine's got the green triangle, so we can open the console and start the graphical install. We're now presented with the same sequence of installation screens as we had for Kali Linux. We'll select English, New Zealand, American English. For the host name, we'll use Purple. I just use any domain name really. And a username and a user ID. We'll use Kali for the user ID and Kali for the password, as we did for our Kali Linux system. Just confirm the time zone. We'll use the entire disk, all files in one partition. We'll confirm and create the disks. And we'll install the base system. Now we've installed the base system, we're asked which of the defensive toolsets do we want installed, and we can select these based on the NIST categories. For our workstation version of Kali Purple, we'll leave them all checked and continue. The installation now runs through to completion. Just before we finish, we're asked whether we want grub loaded, and we do, and we'll continue. Select the drive and install it. We're now ready to reboot, but before we do, we'll go back to Proxmox, and with the purple VM highlighted, we'll select Hardware, the CD/DVD drive, and we'll select Do Not Use Any Media. And we can now go back to Kali Purple, and continue the reboot. We finished rebooting and we're at the Kali Purple login screen. We'll enter Kali, and we're on the main Kali Purple desktop. As we did for Kali, we'll adjust the display size by selecting Settings, Display 1360 by 768, and we'll apply that. We'll change the IP address to a static address. We'll right-click on Network icon, Edit Connections, Wired Connection 1, Tools, IPv4 Settings, Manual, and add, in this case, 192.168.1.101. And we'll make netmask 255.255.255.0 and the gateway 192.168.1.1 and the DNS servers 8.8.8.8, which is the Google DNS server. And we'll save that. And as we did with Kali, we'll disconnect the network and reconnect it to activate the new address. We don't need to change the address to 101 to line up with the VM ID, but it's convenient to do that. Okay, so let's open a terminal window. And as before, we'll press Ctrl P to get the smaller prompt. We'll select Preferences, change to Hack 14 point, and we'll set our transparency to 0 and apply that. Okay. And we'll bring the system up to date by entering sudo apt update and sudo apt -y upgrade. Enter our password, and we can leave Kali Purple to update. That's it. We now have a basic Kali Purple Defense Analyst workstation. Other than being purple, the Kali Purple screen is pretty much what we saw when we checked out Kali Linux. We can click on the application menu and we see the familiar drop-down, but with 5 additional entries: Identify, Protect, Detect, Respond, and Recover. These, of course, are the 5 categories of controls in the NIST cybersecurity framework. As with Kali Linux, we have the menu entries for favorites, recently used, and all applications. The system configuration tools are under Settings, as they are in Kali. Let's check out the tool categories. Many of the tools in Kali Purple appear in both the standard Kali categories and are duplicated in the NIST categories. The exceptions are the password attack tools and many of the reverse engineering tools, which only appear in the Kali categories. In Identify, we have those tools which provide access to known vulnerabilities, or are used to identify vulnerabilities on target systems. Some of these, including AMAS, Maltego, and Wapiti, also appear in Kali Linux, but many of the others are new. Asset Finder, Mariam, and OSR Framework are used to scan for public information on a target domain's assets, particularly useful for finding user-deployed IT systems. Defect Dojo supports DevSecOps by providing a single pane of glass interface and Jira integration to collect testing results. HB Honeypot is a simple Perl-based honeypot which listens on port 443 to detect a heartbleed attack. Tiger is a Linux platform audit tool, and Nipper is a network device configuration audit tool. At the current time, there's only ClamAV, Crypt Setup, and Firewall Builder in the Workstation Protect category. ClamAV is a well-known Linux antivirus tool. Crypt Setup enables disk encryption, and Firewall Builder provides a GUI tool for managing IP tables, pfSense, and Cisco ASA firewall rule. Detect similarly has only the Grok EVT suite and Sentry Peer. Grok EVT is used to read Windows event logs, and Sentry Peer is a blacklisting information sharing tool. The Respond category has a good number of tools, including the Ghidra and Ollie debug software debugging tools used for malware reverse engineering. There are some forensics tools for evidence collection such as DC3DD and EWF Acquire, and incident response tools such as ICAT SleuthKit. The Recover category contains tools useful in recovering information after a natural disaster or malicious attack. In this course, we're focusing on the server applications in Kali Purple, so we won't be spending a great deal of time using the Kali Purple workstation tools. However, now you're familiar with what's available on Kali Purple, you might want to try exploring these tools yourself. In this course, I'm going to show you how to set up some of your cyber defenses with Kali Purple and test them in a virtual lab. Before we take a first look at Kali Purple, let's create our test lab using a virtualization system called Proxmox. If you've already got a test lab set up, you can skip to the next section and get straight into Kali Purple. There are a number of advantages to using a virtual test lab. Virtualization is very easy to set up and avoids the need to purchase racks of computers and networking equipment. Setting up a lab can be done inexpensively, but effectively, using a spare server you might have, or with a low-cost device such as an Intel NUC. In this course, I'll be using a mid-range Skull Canyon i7 NUC. Using a virtual lab for testing allows us to utilize the power of modern processors and ensures that all testing is contained within a prescribed environment, so that test scans and probes don't leak out onto the internet. This is good, as we don't want our legitimate testing activities to accidentally become illegal activities. Virtualization is not only a simple and safe way to do testing, but it also offers a further advantage when stress testing our cyber defenses with attack tools. Using a virtual environment, we can take a snapshot of our application before the testing, and then use the snapshot to recover the lab and remove any traces of malicious activity before our next test. Before we go any further, let's look at what we mean by virtualization. The basic structure of a normal computer is a hardware layer, on top of which sits the operating system. The operating system directly interacts with the computer hardware and controls how the hardware is accessed. On top of the operating system are the various applications which use operating system services and, through them, the hardware resources. For a hardware-level virtualized system, there's another layer, the hypervisor, which sits on top of the hardware. This provides a virtual set of hardware, on top of which sits the operating system and its applications. Using the hypervisor enables multiple operating and application system stacks to operate. These operating systems, with their applications, are called virtual machines or VMs. The hypervisor manages the virtualization of input-output services, mapping virtual machine devices to the hardware devices and managing contention. Microsoft's Hyper-V, which was introduced with Windows Server 2008, is one example of a native hypervisor which is installed on the hardware prior to any operating system being installed. VMware and VirtualBox are two other popular hypervisor systems which can run inside an operating system such as Windows and are known as software-assisted hypervisors. We'll be using another solution, the Proxmox Virtual Environment. It's another native hypervisor, it's open source, and it's extremely easy to use. To learn more about virtualization, take a look at the virtualization courses available in the LinkedIn Learning Library. However, for this course, we'll cover everything you need to know to get started with Proxmox. Let's take a quick look at the Kali Linux interface and the tools that it provides. If you're familiar with Kali, you can skip over this. To start with, Kali Linux is a Debian-based Linux distribution, and its structure and commands are the same as those in Debian and Ubuntu operating systems. For a full understanding of how to use Kali, You'll want to be familiar with Linux. In terms of the GUI, we have a menu system at the left which we can open by clicking on the Kali dragon. We'll come back to this menu shortly. There's a customizable area at the left of the top ribbon. We'll be using the Firefox browser and the terminal from there. The right-hand side of the ribbon contains key system management entries. The first is the network connections icon, which we can use to set our static IP address and manage other networking configurations. There's an audio control, which we'll skip for now, a notifications icon, and then the system settings, which we may wish to review for things such as the various power options such as display blanking and screen locking. Next to that is the manual locking icon, and finally the logout shutdown menu. We can right-click in the display area to bring up a context menu with a variety of functions. Let's go back to the Applications menu. In this menu we have a quick link to a Favorites submenu and to a Recently Used submenu. These two menu items become more useful the more we use Kali. We then have an option to call up a submenu of all applications on the system. This includes all system applications and tools, as well as the categorized applications, which we'll see in the menus below. The Settings menu provides access to the tools used to configure the platform. We've already used one, the display, when we changed the screen resolution. Usual applications are those commonly used on workstations, including a range of accessories, such as the Cherry Tree Note Taker, the Linux PowerShell tool, the SQLite database browser, and more. If we skip down the menu, we find the Internet category has the Firefox browser. We won't go through all of these here, but it's worth you taking some time to review them. The cybersecurity tools in Kali Linux are presented in the Applications menu in categories. We won't be looking at every single tool, that would take a very long time, but we will scan through the categories to get a sense of what they contain. There's a number of submenus and a lot of tools in the Information Gathering menu item. If we open the Network and Port Scanners submenu, we'll find MassScan and Nmap, tools which we'll be using frequently in our career as an ethical hacker. The Open Source Intelligence submenu includes not only the Spiderfoot and Harvester tools, but an installer for Maltego. Maltego is a very powerful open source tool. The most commonly used information gathering tools are listed at the Information Gathering main menu, in some cases duplicating submenu items. The Vulnerability Analysis menu item has a couple of submenus and some of the more useful penetration testing vulnerability tools. For web application analysis, we've got a submenu for content management systems, which has a WordPress scanning tool. And this is a submenu which we would likely populate further with our own selection of tools. The community version of Burp Suite is listed here, and it's one of the main tools used in web testing, followed closely by SQL Map. The Database Assessment menu is fairly light, with SQL Map again and a browser for SQLite databases. There's a few password attack tools, with Hydra, Hashcat and John the Ripper being three popular ones. There's also some pass the hash tools with Impacket and Mimikatz being invaluable. There's a number of good wireless attack tools here, and a couple of reverse engineering tools, which are useful for malware analysis. The exploitation tools include the powerful Metasploit framework and CrackMapExec. Sniffing and spoofing is where we find Wireshark, and post-exploitation tools are useful for gaining additional privileges and establishing persistence, and many of these tools are used daily by ethical hackers. The forensics tools can be useful for collecting evidence and understanding the impact of an attack, and the reporting tools can help collect artifacts that will be used in the testing reports. The final entry, social engineering tools, contains a couple of tools which are useful for preparing a social engineering test. Many of the tools we can use are not accessible through the Applications menu, and much of what we do in Kali is done at the command line. Let's take a brief look at using Kali at the command line. We'll open a terminal window. We'll use Ctrl-P just to get a slightly smaller line, and we'll enter the command echo $shell. We're using the ZSH shell, which is very similar to the bash shell which was used in Kali Linux prior to the 2020 release. We're in our home folder, which as an absolute path is /home/Kali. If we move to another directory and we want to get back, we can use the tilde as a shortcut. If we go to cd/temp, we can then return with cd tilde. Many of the applications in the menus and a number that don't appear in the menus are installed in the user share folder, as we can see, ls/user/share. It's worth browsing through this folder to become familiar with what's here. Another folder which we might find useful to know about is our web root, ls/var/www/html. The Kali workstation comes pre-loaded with both the Apache and Nginx proxy web servers, and so we can see here we have a web root containing both Apache's default index.html and Nginx's default index.nginx-debian.html web pages. As the Kali user, we're operating in user mode, but we can run commands as root by using the sudo command. For example, we might want to look at our log files, which are restricted to privileged users. So we'd type sudo ls/var/log and enter our password. If you want to learn more about Kali Linux, then do take my course Introduction to Kali Linux for penetration testing and ethical hacking. Before we explore the various server systems we can use with Kali Purple, let's build a template for creating them. We'll start the template build by clicking on Create VM. We'll make the VM ID 200 and we'll give it a name of T-Purple to indicate it's a template. That's just our naming convention. We'll select the Kali Purple ISO, and again the guest OS is Linux, so we can leave that. We'll click on the QEMU agent and we'll change the disk size to 64 gigabytes because we'll be building some bigger servers. We'll leave the CPU at 1 and the memory we'll change to 4096 to support our slightly larger server-based systems. Network is fine and we'll confirm and start after created. Okay, we've got the green triangle, so we can now open the console. And we'll start the graphical install. We'll select English, New Zealand location, and continue with the American English keyboard. The host name, we'll call this Temple. And the domain name, we'll just use the same domain name as before, the same username. And we'll continue to use Kali for our Kali Purple installs. Of course, you'd use a production username and password if you were using the systems for production. We'll select the time zone and continue with the defaults for the disk partitioning. And we'll confirm to create our disks. Okay, we're installing the base system. Now we've installed the base system, we're asked which of the NIST toolsets we want installed, but for server use we don't want any of them, so we'll uncheck all of the entries. We'll leave the desktop checked, and we'll continue. Okay, we're being asked whether we want to install the grub loader. We do, so we'll continue. Again, select our hard drive and install the grub bootloader. Okay, before we reboot, we'll go to Proxmox, select Hardware, and set it to use no media, and then reboot. Okay, we're at the main screen, so we'll log in. And as we did before, we'll select the display settings to 1360 by 768. We don't need to change the network address for the template. We'll use Control P just to tidy that line up. We can change our font to Hack 14 and transparency to 0. And we can sudo update and sudo apt-y upgrade. Sudo apt update and sudo apt-y upgrade. Enter our password, and we can leave that to come up to date. In this initial version of Kali Purple, a clean system isn't totally devoid of tools. If we check out the menus, we find that we still have Identify with the Maltego installer. And we also have some remaining reporting tools and OSINT tools. We've now finished updating, and we've made the basic changes to the desktop. So we can close down the Kali Purple server at this point and proceed to convert it to a server template. We'll select the T-Purple entry in Proxmox, right-click, and convert to template. And confirm that. Proxmox adopts a new icon, and our T-Purple now shows as a template. From here on in, when we want to build a server, we can just clone from this template. While Kali Purple provides a workstation for the cyber defense analyst, its real power is in its use as a cyber defense server platform. Here in the Kali Purple wiki, we can see some of the server systems available to run on Kali Purple. The wiki is centered around the Kali Purple reference architecture, which we can see here. We won't be using this architecture, but it's one example of how we might deploy a complete Kali Purple-based cyber defense infrastructure. At the main wiki page, we have 5 NIST categories. If we expand the Identify category, we find 4 entries. The first is an installation entry, which describes how to install Kali Purple. There's also installation instructions for the OpenCTI Threat Intelligence Server and the Greenbone Vulnerability Management Server. Together, these servers form what in the reference architecture is known as Kali Violet. We'll be installing the Greenbone Vulnerability Manager later in the course. While it doesn't appear in this reference architecture, we'll also be installing OpenTaxi, an Identify category Threat Intelligence Exchange server. Under Protect, we see another reference architecture platform called Byzantium. This category provides details of how to install and integrate the OpenSense firewall. The main focus in the Detect category is the installation of the ElkStack SIEM server onto Kali Purple. We'll be covering this in the course, as well as looking at a second SIEM solution called Wazoo, which isn't in this reference architecture. The Respond category provides installation instructions for the Malcolm server. This is a threat hunting solution built by Idaho National Labs and incorporates the Alchemy, Zeek, and Suricata tools. We'll be installing this. While not in this reference architecture, we'll also be installing the Velociraptor incident response server. There aren't any Recover category servers in the reference architecture. The Others category shows a workstation tool called Kali Autopilot, which we'll cover shortly. The Kali Perli reference is essentially a placeholder for any vulnerable server, in this case, a simple install of the Damn Vulnerable Web Application, DVWA. What is Kali Purple? Well, put simply, it's a new variant of the Kali operating system, designed to be used in the cyber defense role. However, this undersells somewhat the role that Kali Purple is starting to play in cyber defense. Let's take a look at what adopting Kali Purple means for cyber defense. Kali Purple is the same underlying Debian-based Linux operating system which has been used by penetration testers for many years. However, the tools it holds are focused not on simulating offensive activities, but on enabling defensive activities. This is a key difference, as it not only provides workstation tools for the defense analyst to use, but it also provides a range of open-source cyber defense servers and services that can be easily set up as part of the cyber defense infrastructure for an organization. Kali Purple is very new, and it's an evolving concept. As it evolves, the cyber defense community will contribute not only to its toolset, but also to the direction it takes as a capability for training and for operational use. The main focus for the initial launch of Kali Purple has been the delivery of a set of cyber analyst tools and servers that can be used in the operational environment for activity monitoring and attack detection, threat hunting, forensics, and incident response. Kali Purple's monitoring capability comes from the ability to easily install the ElkStack seam on the Kali Purple operating system. ElkStack is a solution consisting of the Elastic database and the Kibana graphical interface and query language, together with agents that can be installed on the organization's fleet of endpoints, workstations, and servers for log collection. ElkStack can be configured with alerts to monitor specific events in real time that are recorded in the logs being collected from endpoints. From these alerts, analysts can investigate the logs to determine what activities are occurring and whether they're malicious. A second monitoring and attack detection tool in the initial Kali Purple release is Wazoo. This provides not only the ability to collect and query logs, but it also has a good range of analytical tools and dashboards to scan for vulnerabilities, alert on attacks, and check standards and policy compliance. It has its own host agents which enable remote host investigation. The threat hunting capability in Kali Purple comes from the Malcolm tool, developed at Idaho Labs for the US Department of Homeland Security. Malcolm integrates 5 important tools: the Archemy Deep Packet Inspection tool, the Zeek Session Collection tool, the Suricata Intrusion Detection System, and the OpenSearch database with the same Kibana interface that's used in ElkStack. With Malcolm, we have the ability to hunt through a packet capture at the session level and dig deeper into individual packets to get full details of session activity. Having access to threat intelligence is a key part of cyber defense. The OpenCTI server is included in the Kali Purple repository and is a simple deployment allowing the storage, access, and sharing of threat information. The OpenTaxi Styx Taxi Threat Exchange server has been added to the Kali Purple repository. This makes standing up a threat intelligence exchange server simple, and it comes with the Python libraries to build Styx client software. For forensics, the Kali Purple workstation contains many forensics tools that have grown over the years in the Kali platform. This includes the Ollie debugger, Radar 2, the Sleuth Kit with its autopsy GUI, and a range of carving and imaging tools. Kali Purple also contains a number of new forensics tools, and more are being added with each release. Look out for the Hopper disassembler and debugger, which is coming shortly. The main incident response investigative tool provided in Kali Purple is Velociraptor, an advanced open source endpoint monitoring, digital forensics, cyber response and case management server platform. It enables the incident responder to hunt for specific artifacts and monitor suspicious activities across a fleet of endpoints. This is all using the Velociraptor query language. In addition to the investigative incident response tools, Kali Purple provides the OpenX tool to support the development and running of crisis exercises. This includes standard integration into email and SMS platforms and simulates media interactions. In this course, you'll become familiar with using Kali Purple. We'll explore the tools available in the workstation, and we'll install and run a number of the Kali Purple server tools. We won't be deep diving the tools, but this course will prepare you for your own journey of discovery into the world of Kali Purple and its toolset. Two of the key components of our Proxmox lab will be the standard Kali Linux system, which we'll use as the platform from which to launch attacks within our lab, and the Kali Purple platform containing the key tools to identify vulnerabilities and detect attacks. Let's start by loading Kali Linux. If you're not familiar with this offensive cyber testing platform, check out my LinkedIn Learning course, Introduction to Kali Linux, for penetration testing and ethical hacking. We can get the Kali Linux installation file, an ISO image, from the OffSec website shown here. We'll take the installer 64 image. I've already downloaded this onto my PC. We'll upload Kali to the Proxmox node by selecting Local Disk, Upload, and we'll select the file Kali 2023.3 installer, and we'll change the name just to kali.iso, and we can now click Upload. Now we've completed the upload, we can create a Kali Linux VM. So we'll close this and we'll click Create VM. We'll set the VM number to 100, which is what it is. We'll call the VM Kali, and we'll click Next, and we'll select the Kali ISO, and it's a Linux kernel, so we're okay. At the system screen, we'll click QEMU Agent. At the disk screen, we're going to create a 32 gigabyte disk. That's fine for what we want. And we're happy with 1 core and 2048 megabits memory. The network's fine. And we've now got a confirmation screen. We'll start after created and finish that to create the VM. So that's all we need to do. Once we get a green play button on the VM, we can open the console and we can press enter to start the install. Okay, we're now presented with a series of installation screens for Kali, so we'll continue with English as the language. I'll load this as a New Zealand locality, American English, keyboard. Okay, we now need to enter a host name for it, and we'll call that Kali. And the domain name doesn't really matter, but we'll put that in. The full name for the user, we'll put in Kiwi. And we'll use Kali as the username, and Kali as the password. Okay, so now we'll take the defaults for installing on the disk, which is to continue to use the entire disk and put all files in one partition. And we'll finish partitioning, and yes, we want to write the changes to disk. So we're now going to set up our disk with the Kali Linux operating system. And we'll come back in a few minutes when it's loaded its base system. The base system's installed, and we're now asked whether we want the Kali offensive tools installed. We'll accept all of them and press continue. The tools have now been loaded, and we're asked if we want to install the grub loader, which we'll need to boot into Kali. We'll confirm that. And we'll enter the device. The installation has now completed, and the system's ready to reboot. Before it does, we'll go to the Proxmox screen, and with Kali highlighted, select Hardware, double-click on the CD/DVD drive, and select Do Not Use Any Media. And we can reboot now. We're finished rebooting and we're at the Kali login screen. We'll enter Kali and Kali for the password and log in. And we're in the main Kali desktop. The first thing we'll do is to adjust the display size by going to the menu, Settings, Display, and selecting 1360 by 768. Apply, and we'll keep that configuration. We'll change the IP address to a static address by right-clicking the network icon, Edit Connections, Wired Connection, click the Tools icon, IPv4 Settings, and change to Manual. We'll add an address 192.168.1.100, and we'll put a net mask in of 255.255.255.0 and a gateway of 192.168.1.1. And for the DNS server, 8.8.8.8. And we'll save that. And we need to click on our network icon, disconnect, and then reconnect. And our IP address has changed. The last thing we'll do for the moment is to open a terminal window. We'll change our preferences to hack and the size to 14. And we'll change the transparency to 0. And we'll bring our system up to date by entering sudo apt update, and after that sudo apt -y upgrade, and that will bring all our tools up to date. Okay, we can leave Kali now to complete its upgrade, and it'll be ready for use. The Juice Shop is a sophisticated and vulnerable website written in Node.js and distributed by OWASP. Let's install this on our web server. Firstly, let's install the Node.js and npm packages that we need to run this. Sudo apt install Node.js and npm. We'll enter our password and continue. We can now clone Juice Shop from GitHub. Git clone https github.com juiceshop.git. We'll go into the Juice Shop, cd Juice Shop, and then we'll run npm install to rebuild the system. This will take a while, so we'll let that run. Okay, that's finished, so let's start Juice Shop up, which we can do with npm start. And the server's now listening. So let's open up Firefox and browse to Juice Shop on localhost 3000. And here we have our Juice Shop. Okay, let's stop this. We'll want Juice Shop to run on startup, so let's create a service for it. Firstly, we'll create a script for npm startup. Nano juice.sh, and we'll make this #bang /bin/bash cd/home/ubuntu/juice shop npm start. Okay, and we'll make that executable, gmod +x, and we'll now set up a service file to execute it. Sudo nano /etc/systemd/system/juice.service, and we'll create a unit saying description equals OWASP juice shop, and after equals network.target, which is when it will start. Service type is simple. User equals Ubuntu. Group equals Ubuntu. Exec start equals /bin/bash. And we're going to start up the script in home. Ubuntu juice shop juice.sh. And the install section is wanted by is multi-user.target. Okay. And we'll enable that service. Sudo system control enable juice. And that's it. We're ready with a target set up to test our attack detection skills. We've built Nginx as the proxy providing an entry point into our lab. Let's give it an intrusion detection capability by installing the Suricata IDS. As a production system, we'd load this as a standalone Kali Purple IDS, but to minimize the number of servers we need for our lab, we'll install it on our proxy server. Okay, so let's install Suricata and the additional packages it needs. Sudo apt install Suricata, JQ, GNU PG2, and software properties common. I'll enter our password and confirm. Okay, we need to update the configuration to specify our home network. We do that with sudo nano /etc /suricata /suricata.yaml. And we'll change home net to 192.168.1.0/24 and save that. Okay, let's now fetch our default rule sets, which we do with sudo suricata update. And finally, we'll enable and start up Suricata. Sudo systemctl enable Suricata, and we'll start it up now. Let's check we're detecting bad things. We can send a curl command to a URL testmynids.org/uid/index.html. And this will return a known bad message. And this is a standard response which should trigger an alert. So let's check the log. Sudo cat /var/log/suricata/fast.log. And we can see here we've generated an alert. We've now got a proxy server with IDS capability. While building our own vulnerable servers allows us to create what we want in our lab, it is a lot of work. An alternative would be to load an existing vulnerable server. Metasploitable 2 is an entry-level test server. It's provided not as an ISO, but as an OVA virtual machine. This doesn't import directly into Proxmox, but we can, with a few simple steps, import the virtual disk. Let's do that. The first step is to create the Metasploitable 2 VM. To do this, we'll click Create VM, and we'll call it 113 Metasploitable. On the OS screen, we'll click Do not use any media, and we'll accept all the other defaults. And we won't start, we'll just finish. Okay, we now have the VM, and we need to select it and go to the hardware details and remove the hard disk. We do this by selecting it and clicking Detach. And yes, we want to detach that. We can then select the unused disk 0 entry and remove it. And yes, we want to remove that. I've downloaded the Metasploitable 2 image into our Kali VM. We can unzip this by saying unzip Metasploitable 2 and Metasploitable-linux-2.0.0.zip. Okay, and we can now cd into the Metasploitable 2-Linux folder. The file we want is the main virtual disk called metasploitable.vmdk. Let's set up a web service so that we can fetch this into Proxmox. We'll do that with Python 3 -m http.server. And we're serving that folder up over HTTP on port 8000. Back in Proxmox, at the main node, we'll enter shell and copy in the disk. wget http 192.168.1.100, which is our Kali machine, port 8000. And what we want is metasploitable.vmdk. Okay, now we've copied the file into Proxmox, we can import it to the node using Proxmox import disk utility. qm import disk 113, and what we're going to import is metasploitable.vmdk, and we'll put it into the local LVM storage, and the format we're going to use is qcow2, which is a standard virtual image format. Okay, that was successfully imported. Now when we check our Metasploitable image, hardware, we have a disk showing up as unused disk 0. We'll select it, change the type to SATA, and we'll add. And we now have a hard disk. Our final task is to select Options, Boot Order, and uncheck the existing options and check our Metasploitable disk. Okay. We can now start the VM and open the console, and we've got a running Metasploitable 2 server. Another source of virtual machines from entry-level to advanced is the community-provided VulnHub repository. There are many systems here, each providing a different set of vulnerabilities and available for free download in OVA form. We can install these directly into VirtualBox or VMware, or we can load them as virtual disks, as we did for Metasploitable 2, into Proxmox. Loading OVA files into Proxmox is a bit fiddly, but once we get the hang of it, there's a lot of pre-made servers that we can take advantage of. Let's set up a public website in our Nginx server. For this, we'll use the Project World's gym management system. We'll switch to root and install this into our web home folder. Sudo su and cd/var/www/html. And we'll wget https projectworlds.in wp content uploads 2021 10 gym management system project in php.zip. Okay, we're downloading that now. Okay, we'll now unzip this. Unzip gym management system project in php.zip. And we'll rename this to just gym. Move gym management system project in PHP to just Jim. We'll make this accessible for the Nginx server by changing its ownership recursively to www.data www.data for the whole Jim folder. And let's go into the folder. Okay, let's list our contents. And we can see we have a file table.sql. That's the definition of our database. So let's use MySQL now. -u root -e, and we'll create database Jim, use Jim, and we'll source table.sql. And that will import the table SQL commands and set up our database for us. We now need to update two files with our administrative password for SQL. Nano include /dbconnect .php, and we'll change our user ID to support, the password to support, and table to Jim. Save that. And also PSL config include /PSL config.php. And again, change our user to support, change the password to support, and we're already set to Jim in the PSL file. And that's it. Okay, we now have a running website. Let's browse to it. And we'll go to localhost/Jim. And here we are. We'll come back to this website as we test out the Kali Purple tools. In a production environment, we'd want to have our proxy server configured with an internet-facing interface, but with a second interface into an internal network. However, we'll keep it simple for our workshop and run all of the hosts on a single subnet. Let's create the first application server for our lab. We'll use a Ubuntu Live server as the platform for this. I've already downloaded a Ubuntu 2022 image from the website shown and uploaded it to Proxmox. We'll create VM. We'll set the VM ID to 111 and we'll call this Apo1. And here we'll select Ubuntu as the ISO. It's still a Linux system, so we don't need to change that. We'll select QEMU agent, and we'll leave the disks, CPU and memory all at the same default settings. We'll check Start After Created and Finish. Okay, the VM's been created and it's started. So let's open the console and we can press Enter to install the Ubuntu server. Once the initial boot's been completed, we'll be asked a number of questions as part of the operating system setup. We'll select English for the language, and we'll update to the new installer. Okay, that's done. And we'll accept the keyboard layout. We'll accept a Ubuntu server build. We'll accept the network. We don't have a proxy. We'll accept the mirror. We'll use the entire disk and tab down to Done. And we're happy with the disk setup and we want to continue. We'll put Kiwi in for the name, the server name, Apo1, pick a username of Ubuntu, password of Ubuntu, and we'll confirm that. We'll skip Ubuntu Pro for now, but we do want to install an SSH server. Okay, we don't want any snaps, so we'll just go straight into the build. And we'll let Ubuntu build. Okay, that's finished, so we can tab down and reboot now. And we'll have to go in and select hardware and remove the disk. Do not use any media. And then press enter for the reboot. Okay, we've now got a working Ubuntu platform, so we can log in. And we use our credentials Ubuntu. We'll update and upgrade our platform now. Sudo apt update and sudo apt-y upgrade. And we'll enter our password again. Okay, there's a few common tools that would be good to install, so let's do that. Sudo apt install build essential, curl git wget unzip lsb release umu guest agent, which will give us the link to Proxmox from the Ubuntu system, GNU PG CA certificates, net tools, apt transport https, and we'll get Python 3 minimal, Python 3 setup tools, and Python 3 pip. Okay, and let's wait for this to finish. We'll reconfigure this VM to have a static IP address. We can do this by modifying the network file. Sudo nano /etc /netplan /00 installer config .yaml. We'll change DHCP4 to false. We'll put in addresses colon, and then the list of addresses will only have 192.168.1.111/24. Gateway 4 192.168.1.1. Name servers addresses 8.8.8.8. Okay, we can save that and we'll restart the server. Okay, we now have a Linux application server we can use for testing. We've set up our Kali Attack workstation, our Kali Purple Cyber Defense workstation, and we've set up some websites and servers as targets. We can now manually create and run attacks. However, a better option for training as a cyber defender is to be able to have an attack automatically run so that we can attempt to detect it in real time. Even better, running a multi-stage attack as a kill chain allows for a more complete training experience. Kali Purple provides an attack generator called Kali Autopilot for exactly this purpose. Kali Autopilot is pre-installed on Kali Purple, so let's start it up. We'll open our terminal and type Kali Autopilot. Kali Autopilot is a GUI which captures the requirements for an attack and then generates a Python script. The Python script can then be loaded into a workshop environment and, when run directly with Python, will automate all steps in the attack. It's important as we build our attacks to remember that the purpose of the attack script isn't to try to penetrate a target, it's to simulate an attack in order to train cyber defenders. This means we script the attack knowing what we'll get back from a command. We don't need to read the responses. Let's start by building a simple attack to demonstrate the use of Kali Autopilot. Kali Autopilot provides a repository for attack scripts, and these are shown in the list box at the left. We currently have none, so let's add one. We'll enter learning as the script name and add. Note that the script title in the top middle box changes to Learning. We now have an empty attack script definition. The top middle panel is used to define variables which we can use in the script, with the values being inserted at runtime. One of the key uses for this is to define host names and associate them with an IP address. We'll enter a subnet and two host addresses. Subnet 192.168.1.0/24, web01 192.168.1.110, and app01 192.168.1.111. Okay, we can click the Save button at any time to save what we've put in so far. The top right-hand box contains some global settings which are referred to when generating a script. The top line allows us to enter a range to be used to insert delays in between attack steps. This will be used if we check the box Always Insert Delay. We can include diagnostic output to be shown by checking the Debug checkbox, which can be useful when we're testing new scripts. Finally, if we check the Loop checkbox, then once the attack terminates, it will loop around to start the attack again. The bottom panel is where we define the attack steps. These each consist of up to 4 values: the action to be taken using Kali Autopilot keywords, a reference value, a prompt value, and a command field. Let's learn by example how we use these. We can use the action stage and a sequential number in the refer field to define stages in the attack. The attack will wait at a stage command for manual intervention to allow the attack to continue. This is a useful feature when running a workshop, as it allows participants to work through the attack one stage at a time. So let's start by entering stage 1. We can leave the remaining 2 fields blank. In our attack script, this will generate a check which will wait for the stage, which is initially 0, to be set to 1 before continuing. We'll cover changing the attack stage shortly. The first step in the attack might be to run a scan of the target subnet looking for active hosts. An attacker would typically use the Nmap tool for such a scan, and in Kali Autopilot we can run this using the operating system command. We enter the line OS, and we don't need a refer or a prompt, and we can just enter here Nmap -SN, and we can type the subnet, or we can use our abbreviation Embraces. This will generate in the attack script an Nmap scan command, which it will run as a shell command on the attack script host. If we have the global configuration set to include delays, then the script will precede this with a random delay in the specified range. With this command, we've simulated the attacker enumerating our network to find some active hosts to attack. In generating the script for a workshop, we don't need to get the results of our commands, as we've already choreographed the attack. We can assume that we detect web01 and app01, and now scan them for services. We'll use OS, Nmap, -PS, -SV, and in this case, we'll look at web01. OS, Nmap, -PS, -SV, app01. We'll then conclude our attacker's reconnaissance by running an enumeration against the website. We'll do that with another OS command to run dirb, and we'll run that on http://web01. We'll now start a brute force attack against our identified app01 host to try to find a set of valid credentials. An attacker would use a tool such as Hydra to do this. So let's run another operating system command to test for these credentials. OS, Hydra, -L, and we'll assume that we have a known user ID called actar, but we'll use a password file, pass.txt, to look for a password. And we're going to do that against the SSH service on app01. Okay, this then simulates an attack on the known user account actar using a password file in an attempt to find the password. As noted previously, if we're using delays, then there'll be a random delay generated prior to this command being executed. We've put the correct password into the pass.txt file, so this scan will find an active account that we can use. We then simulate using it to get a successful login to an SSH session. We don't need to use braces around the target name in this particular command. SSH, and we'll use a refer as one so that we can refer back to this shell. And the commands are the parameters for the SSH call, which are the IP address, the port, the username, and the password, which we know, and the attacker will hope to find out by doing the Hydra command. We'll now run an exploitation, this time against the GIM website, which we assume that the attacker found in the earlier web server enumeration. The exploit is one that comes from the exploit DB set of exploits. We've already installed the web server. I've already prepared the Python exploit code. We'll run the exploit knowing that we'll get a shell back using a command line prompt of greater than, and we'll call this shell2, shell2, and the prompt is greater than. We need a prompt for the shell command or the shell action. And the command we're going to run to get this shell is Python 3, it's a Python script, xgim.py, and the command line parameter for that is http web01 gim. The attack script will now receive a remote shell prompt as a result of the exploit and can issue commands using a command action. We'll list the password file and then close the exploit. Command on shell2 this time, and our command is going to be simply cat /etc/password, and we'll issue a second command, exit, to terminate the exploit. Okay, that's our attack written, so let's save it. And now let's press the generate button to produce our Python script. We'll start the build of our lab by setting up an Nginx server. This will provide us with a proxy service for web, a proxy service for streaming protocols such as SSH, and it enables us to provision internet-facing web servers. Let's get into it. We'll first of all clone our Kali Purple server from the Kali Purple template. We'll right-click and clone, change the VM ID to 110, and we'll give this a name in Proxmox of Web01. We'll make it a full clone and clone it. Okay, that's finished, so let's start it up. Open the console and log in with our credentials Kali. We'll change this VM to have a static IP address. Right-click, Edit Connections, Wired Connection Tools, IPv4 Manual, and we'll add the address 192.168.1.110, and we can put in a shortcut of 24 for the net mask and 192.168.1.1 for the gateway, and 8.8.8.8 for the DNS server. Okay, we'll close that and we'll disconnect and reconnect to activate the address. Open a terminal window. Do Control P just to get the short prompt. Nginx is loaded by default as part of the tools in the Kali Purple workstation, but we want to put this on a server platform, so we'll have to manually load it. We'll install the MariaDB SQL database and the services we need to support PHP. Sudo apt install nginx, php mysql, php fpm, MariaDB client, and MariaDB server. We'll enter our password and confirm. Okay, we're done. Let's just check our PHP version, because we'll need that in a moment. And we're PHP 8.2 as the major and subversion. Let's now update the Nginx configuration to accept PHP. To do that, we edit the default website configuration. Sudo nano /etc /nginx /sites enabled default. And we'll scroll down, change the location for PHP to uncomment it, uncomment the include, uncomment fast CGI pass, and change PHP from 7.4 to 8.2, and uncomment the closing bracket. We'll also add another location so that we can call for the status of Nginx, and we'll do that by putting in location /Nginx status stub status and close it off. We can now save the changes, and we can enable Nginx and PHP. Sudo system control enable Nginx, and if we use -- now, it'll start up as well. And sudo system control enable PHP 8.2-fpm now. Let's now add an administrator account to our MariaDB MySQL service. We need to enable and start up MySQL and then send a command sequence to it. So again, sudo system control enable MariaDB -- now, and then sudo mysql -u root, so we'll do this as the root user, and issue the command grant all privileges on ** to, and we'll use the name support at localhost identified by a password of support as our administrative user for MySQL. Finally, we'll change the internal server name to web01, sudo host name control set host name web01, and we'll reboot. When we come back up, let's log in and make a change to our hosts file so that web01 resolves properly. We'll log in with Kali. We'll open a terminal and sudo nano /etc /hosts Kali, and we'll change the host file to web01. Okay, that's it. Let's install a Windows 2019 server as apo2. We can download a Windows 2019 evaluation server image from the Microsoft site shown here for use in our lab. We'll create a new VM with an ID of 112. We'll call it apo2, and at the OS screen we'll pick up our 2019 ISO that we uploaded, and we'll change to Microsoft Windows and select 2019 server. The system will run a QEMU agent. We'll increase the disk to 64 gigabytes. We'll put in 2 cores, and we'll change the memory to 4 gigabytes. And we're happy with the network. We'll confirm and start after created. Okay, it's started, so we'll open the console. Okay, we're asked to confirm our language settings, which we'll do. and we'll install now. We'll select the standard evaluation desktop experience, accept the terms, and we'll do a custom install and select the drive that we'd created, and Windows starts copying its files. Okay, we're now asked to enter a password for the administrator account. This has to be one which meets the Windows password requirements, and we'll enter Kakapo42 and confirm as Kakapo42 and finish. We now have our app server running, so let's log in, and we'll show the extra keys, Ctrl-Alt-Del, and administrator Kakapo42 will be discoverable. We don't need to show this message again. On the desktop, we'll right-click Display Settings, and we'll change our settings to 1280 by 768. And we'll keep the changes. We'll right-click on the network icon, open the network and internet settings, change our adapter options, properties, IPv4 properties, and we'll use the following IP address: 192.168.1.112. The gateway is 192.168.1.1, and we'll use 8.8.8.8 for our DNS. OK, and close, and close, and close. The final thing we need to do is to install the QEMU agent into Windows. A download link to the QEMU ISO is shown on the Proxmox page here. I've downloaded this and uploaded it to Proxmox, so let's install what we need. In Proxmox, in the hardware section, we'll go to the CD drive and we'll replace the Win 2019 ISO with the VirtIO ISO. Back in Windows, we'll open the CD, we'll go to Guest Agent, and we'll install QEMU Guest Agent x86-64. Double click that, and we'll then go back up to the main folder on the CD drive, and we'll install VirtIO Win GT x64. Next, accept the terms and conditions, and install. OK, that's finished. We can close that. We can go back to Proxmox and remove the VirtIO drive, and we have a running Windows application server for our lab. Now we've generated the script, we can use it to run our attack. We have our attack tools in the Kali workstation, so we'll run it from there. Let's review what our script does. We're scanning for targets, then enumerating the web server, brute forcing our way into SSH, and then running a web exploit. OK, let's get a web server set up to transfer it. We'll move to Kali, Auto, Pilot, Learning, where the script was generated, and we'll set up a web server with Python. Python 3-m http.server. OK, in Kali we'll duplicate the folder structure and we'll pull the attack script over to Kali. Make dir Kali Autopilot cd Kali Autopilot. Make dir learning cd learning. And we'll get from http 192.168.101 on port 8000 our learning.py script. Okay, we have that. We've used two external files in our script, a password file and the Gym exploit script, and you'll find them in your exercise folder. I've already downloaded these, so let's move them in here. Copy downloads xgym.py to here, and copy downloads pass.txt to here. Okay, we can now run the script. We can see we've got Web01 and App01 VMs running, and I've already created the Actar account in App01. We'll run our attack script at the command line with the command python 3 learning.py. Okay, this is waiting to start, so let's use the attack script management interface to start it. We'll open up Firefox and navigate to an endpoint the attack script has made available. http 192.168.1.100, which of course we could just use localhost. And the endpoint is check, to check the state of our attack. We're asked to put in a username and password, and the defaults in the script are offsec, offsec. And we sign in with them, and the attack is at stage 0. So let's move it forward to stage 1. And there's another endpoint we can use called set, and the parameter to that is mutex equals, and 1 is the attack stage we want to run. And attack stage 1 is now running. We can see the script has processed our web commands, and the attack's now started with the mmap scanning. And here we see the derb command checking the web pages on Web01. And here we see Hydra doing its brute force attack. And Hydra successfully found the password. And here we see our Gym exploits in action. We'll leave this attack here for now, and we'll get plenty of chance to practice attacks as we proceed through the course. Okay, before we run a scan, let's check our administration feed status, and we can see we're all current. Let's now run our first scan against the Metasploitable server. To run a scan, we select Scans, and we'll use the wizard denoted by the wand, Task Wizard, to do an immediate scan of 192.168.1.113, which is our Metasploitable server. And we'll start the scan. In the status, we can see that the scan has been requested. Okay, the scan has now been queued for action and it's started. We'll let this scan complete and then come back to it. Our scan has finished and the scan screen shows one report. We can click on the report number or date to open it. The report screen information tab shows the task name and the time taken for the scan. We can select the results tab, and we can see we have a lot of high severity issues, starting with a possible backdoor, some XSS and command execution vulnerabilities, operating system end of life, multiple distributed Ruby remote code execution vulnerabilities, and more. Let's take a look at the distributed Ruby remote code execution. We're presented with a summary of the issue, and the methods used, and the results of detecting it. The impact is described, in this case the ability to run privileged commands remotely on the Metasploitable server, and some approaches to mitigating the issue are provided as the solution. We can click on this again to close it. The Hosts tab shows the hosts involved in the scan. In our case, we just scanned the one host, but we could scan multiple hosts by including a subnet expression or multiple IP addresses. The Ports tab shows those ports that are active on the host, together with the severity of the vulnerabilities relating to that service. The Applications tab shows the applications running on the server and the severity of the vulnerabilities associated with each application. The Operating Systems tab shows the operating systems involved in the scan. GVM reports the Metasploitable platform as being Ubuntu 8.04. And we then have a CVEs tab, which shows the National Vulnerability Database reports related to the vulnerabilities found. We can select these to check more details about each vulnerability if we wish. The TLS Certificates tab shows the details of crypto certificates associated with two secure services, email on port 25 and the PostgreSQL service on port 5432. Running a scan is the primary function of GVM, but there's a lot more in GVM relating to the management and scope of scans and the recording of assets found. Our focus in this course is getting the tools up and running on Kali Purple, rather than deep diving the capabilities of the tools, so we'll leave GVM here. However, you might find it useful to explore the GVM console to become much more familiar with its capabilities. And you can check my web ethical hacking and penetration testing courses for more details on web scanning and testing in general. In addition to its workstation tools, Kali Purple has an optional vulnerability scanning tool which can be installed either for local use or as a standalone server supporting multiple concurrent users and scans. This is the Greenbone Vulnerability Manager, GVM. Let's install this on a Kali Purple server. I've cloned the Kali Purple template and we now have a server called GVM. So let's sudo apt install the GVM tool and enter our password and confirm. We can now move straight into the GVM setup phase, which will load its databases. Sudo GVM setup. Okay, we can see our admin password, which we'll need later, and it'll be repeated at the end of setup. Downloading the database information will take a while, so let's come back when it's complete. We're now finished. Let's copy our password, as we'll log in shortly. By default, GVM runs on localhost only, and we access it from within Kali Purple on IP address 127.0.0.1. However, if we want to access it both locally and remotely, we can do this by updating the GSAD service specification. And we do that with sudo nano /lib/system/system/gsad.service. Put our password in, and we'll change the execution start, from just localhost on 127.0.0.1 to 0.0.0.0, which will listen on any IP address for port 9392. Okay, we can save that. And we'll restart the GSAD service with sudo system control restart GSAD. And we'll now log in with https localhost :9392, and we'll accept the risk. And here we are in Greenbone Vulnerability Manager. We'll put admin and we'll paste our password and sign in. One of the first things I'm going to do is go to users, and using the new user icon, I'm going to add a login name of Cybex with a password of Cybex, and the role will be admin. That will give us an easy way to log in, and we'll save that. Okay, we've got a new user now. Now let's check out administration feed status. We can see on 3 of our feeds, update is in progress. We need to wait for these to complete before we can move on. This can take in the order of hours to complete, so we'll finish here and come back to run a scan once the feeds have been fully processed. A key means of defending against attack is to patch any known vulnerabilities in our systems. Many applications are now accessed through web portals or built as web applications. Understanding our web vulnerabilities is an important and proactive way to achieve effective cyber defense. Kali Purple comes preloaded with the OWASP vulnerability scanner Z-Attack Proxy, or ZAP. Let's see how we can use that to do a basic vulnerability scan of a website. We start ZAP from the Applications menu, Web Applications Analysis. We'll accept the default of not persisting the session and start. Let's select the automated scan and enter our URL to be tested. We'll test the DAM vulnerability web application, which is running on our Metasploitable server. And this is on IP address 192.168.1.113/DVWA. And we'll start the attack. If we expand Sites in the Site panel and expand DVWA, we can see the pages being scanned. ZAP begins by spidering the site, doing some basic checks as it goes. It then runs an active scan on the pages it's found to look for additional vulnerabilities. OK, we've completed the attack, and we can see in the bottom left panel a list of alerts. If we check the top one and expand it, we see there are 2 post messages which cause this alert. And if we select it, on the right we get the details of the alert. If we scroll down, we can see that the solution to this vulnerability is to upgrade to the latest version of PHP. Do take a moment to generate a report of this scan yourself by selecting Reports, Generate Report. Now we've got our SIEM server running, we need to think about sending logs to it from the host we want to monitor. The first thing we need to do is to set up details of what kind of information we want collected. We do that through what's known as integrations. So using the main menu, we'll scroll down to Management, Integrations. So we can see there's a large number of integrations that we can install. Let's see what we've got installed by default. We can see we have 3 integrations: the System Agent, the Elastic Agent, and the Elastic Synthetics Agent. The System Agent will provide the basic monitoring information that we want. However, there's more we can usefully consume. Let's go back to Browse Integrations, and we'll scroll down until we find OS Query Manager. This integration will enable us to issue commands from the server onto the hosts that we're monitoring in order to investigate any issues we detect. So we'll select that and we'll add OS Query Manager. We'll leave the integration name as OS Query Manager 1. And where do we want to add this integration? We'll call that a policy called Linux. OK, that's done, and we'll select Add Elastic Agent later. Go back to Integrations. And the next integration we want to add is Nginx. This collects logs from an Nginx web server. We have one, so we'll select this. We'll add Nginx. And we'll leave that as Nginx1 for its integration name. And where to add this integration, we'll go to Existing Hosts. And we'll change our agent policy to Linux. And we can now save and continue. OK, again, we'll add the Elastic Agent later. Go back to Integrations. And the next integration we'll add is Suricata to pick up our IDS logs. We'll add Suricata. We'll leave it as Suricata 1, and again we'll go to existing hosts and add this to our Linux collection and save and continue. And we'll add Elastic Agent later. We'll go back to integrations, and the final integration we'll add is Windows. We'll add Windows. We'll leave the integration name as Windows 1. Down here, where to add this integration, we'll call this Windows. And we'll use a new policy and save and continue. And add Elastic Agent later, and back to integrations. Okay, we've now got the basic log collection set up for our Linux and Windows hosts. Earlier in the course, we took a look at Kali Autopilot and generated an attack script called learning.py. I've updated this to include a stage between reconnaissance and exploitation and added a few SSH commands. I've moved this over to my Kali system, so let's now run the script and monitor it using elk. cd Kali autopilot /learning and Python 3 learning.py, and we'll start the script. Now let's go to our elk monitoring screen. We'll enter our credentials, which are CyberX. Let's check that our fleet monitoring is healthy. We can do this by navigating to our management fleet and checking our fleet hosts. It can sometimes take a few minutes for the fleet server to synchronize with its agents. And if we have a host which remains offline after allowing a reasonable amount of startup time, then we can usually resolve it by restarting its Elastic Agent. As it is, we're fine. Let's now go to Discover, and we'll select the data sources logs, and we'll set our time frame to a 15-minute window, and we'll refresh every 10 seconds and apply that. Even in our workshop system, we have thousands of logs showing in our monitoring window, so we might usefully reduce some of the noise. This requires that we understand the logs we're getting and we know what's normal and what isn't, and that takes experience. Elk collects both activity logs and system metrics. For our purposes, we can filter out the metric beat logs. We're also getting a lot of noise from Suricata, as we haven't tuned it yet, so we'll filter these out for the moment. We can do that with one filter statement. Not event dot dataset, and we'll exclude the datasets elastic underscore agent dot metric beat and suricata dot eve. Okay, so that reduced the logs we're getting. There's still a lot of logs showing, but we can see that we've substantially reduced the new logs being shown. Once the older logs work their way through, we'll be down to a low noise level. Let's check our attack. We can do that by navigating to 192.168.1.100/check. As expected, we're at stage 0, waiting for the attack to be initiated. Let's initiate it. We'll call set mutex equals 1. We'll now wait and watch. Activity continues as normal for a while. And then we detect a spike in the logs. In this case, we've got just under 1,000 entries. The standard ELK log display isn't helping us, so let's select a couple of useful fields to get a bit better overview of what's happening. We'll select host name and message. We've detected another big spike of traffic with around about 4,500 log records. Things appear to have quietened down now, so let's stop the real-time update and examine what we've seen. At this stage, it's useful to take a note of what we think is the start and end time of the event. We'll update the time by clicking the time entry field and setting the start and end time in absolute form. So our event started at around about 10:29 and went on until 10:32. Okay. This provides a much more useful histogram showing the progress of the log activity. We can click on an individual bar to show that in detail, and then return to the previous screen to come back here. Let's start by selecting the first smaller spike of logs. Okay, this is one event focusing on Web 01, and we can see in the message field that this shows a source and destination address. We can also see the source and destination ports. As we look down the list, we can see that the IP address is the same, but the source and destination ports are changing. These are our enhanced logging records from IP tables. What we're seeing here is a pretty standard Nmap scan from the source address 192.168.1.100. Let's now go back to the full event. And let's select one of the bars from the larger event. Okay, we're still looking at Web 01, but there's no message showing. Let's open one of the records. We can see that this is an Nginx log, and we can also see that the event outcome was a failure. On the second page, we can see this was an HTTP GET request. And on the third page, we can see the URL this request was attempting to access. Okay, let's close this and let's go back and add to our display url.path. Now as we scroll down the logs, we can see lots of URLs in alphabetical order. This is typical of a Derby scan. At this stage, we know that we're being targeted, and someone has enumerated our hosts, and that our website has been scanned. Before we can enroll any systems to be monitored, we'll need to set up a fleet server, which is the component of ELK that handles interactions between the ELK stack server and the hosts we're monitoring. To do that, we go to Management, Fleet, and as suggested, we'll add a fleet server. We'll enter the name as ELK stack and the URL as https 192.168.1.102, and it uses port 8220 for fleet server. And we'll generate fleet server policy. Okay, so ELK stack has now provided a command to load the fleet server. Let's copy it. You can use with the copy icon. Okay, let's become root and go to the root folder. Sudo su, put our password in, and cd/root. Okay, we'll nano fleet.sh and paste the clipboard in. For simplicity, After we've downloaded the agent, we'll move the Elastic Agent folder name and call it L-Agent, and then cd L-Agent. And we'll install the Elastic Agent Fleet Server, and we'll add the ---- in secure flag to avoid problems with certificates. We'll save that, and we will make that executable, and we'll execute that. Okay, we're receiving the Fleet Server, and back in Elk Stack we can see that we're waiting to confirm that the Fleet Server has been installed and is connected. So we'll come back to that when it's finished. Okay, we're downloaded and we're asked if Elastic Agent should be run as a service, and we'll take the default yes. Elastic Agent has now been successfully installed, and if we go back to Elasticsearch, we find the Fleet Server has connected. And in the Fleet display, we find we have Elk Stack running the Fleet Server policy. We're in our Web01 proxy. As our main interface to the public network, the proxy is a key point to monitor remote access to our systems. A good way to do this is by using the Linux IP tables tool. It isn't installed by default in Kali Purple, so we'll install it. Sudo su, and we'll get a root session, and we'll do our work from the root folder, and we'll apt install IP tables. We can add a rule to generate a log for each new connection attempted, whether it was successful or not. However, changes to IP tables are ephemeral and need to be reloaded on a reboot, so we'll create a service to do that. In addition, we have Suricata running on the proxy, and it can generate a lot of logs. So to avoid bulking out our storage, we'll clean them each time we reboot. We can do that by truncating them. Firstly, we'll create a small Python script, nano check.py, and we'll import the operating system library os.system, and we'll truncate -s 0/var/log/star, and any errors we'll send to /devnull. Okay. And similarly for our audit logs, os.system truncate -s 0/log/audit/star to /dev/null. And then truncate -s 0/var/log/suricata/eve.json. And then we'll add our firewall rule, which we do with the IP tables command, IP tables -a input -ptcp -m, and we're looking for our state, and the state we're looking for is a new connection, and when we find one, we log. Okay, and we'll save that. We now need to create a service to run this, and we'll do that nano/etc/systemd/system/check.service. And in here we have a unit, description equals boot up tasks, after equals network target, the service type is simple, the user is root, and exec start equals /user/bin /Python 3. And what we're going to execute is /root/ check.py. And we'll say it's wanted by the multi-user target. Then just the standard service definition. Control X, and then we'll enable it with system control enable check, and we can run that now. Okay. For app 01, we'll add some enhanced SSH logging using an SSH feature known as force command. As we're going to be making changes to SSH, we'll do this from the console. I've already created a small bash script, so let's have a look at it. Sudo nano /user/bin user/local /bin /log SSH. In this script, we're checking that the SSH connection includes a command, and then we're using logger to copy it with the SSH prefix to syslog. We're then executing the command. Okay, we'll set the access sudo chmod 755 /user/local /bin /log SSH. We now need to update SSH's configuration, which we do with sudo nano /etc /ssh/sshd config. And at the bottom of the configuration file, we'll add the line force command /user/local /bin /log SSH, and save that. And we'll sudo system control restart SSHD. The final enhancement we'll make is to install sysmon into Windows to generate additional logs. We'll open a privileged admin PowerShell, run as admin, and we'll get https github.com swift on security sysmon config raw master sysmon config -export xml -out file sysmon.xml. We'll update the sysmon event 10 entry. We can use that using Notepad. Event ID 10 in between the process access, process not access tags. We'll remove the comment and put in target image condition equals is :/Windows /system32 /lsas.exe in order to get all the security system logs and /target image. And we'll save that. And we'll now get download .sysinternals.com files sysmon.zip -out file sysmon.zip, and we'll expand archive sysmon.zip -destination path dot where we are, and we'll run sysmon.exe, run sysmon64.exe, and install using sysmon XML configuration file and we'll accept the EULA, and we'll specify our hashes as MD5 SHA-256 -N -L. Okay, and we've got sysmon running. Okay, and we can now check system services on APO2, and we find we have sysmon 64 running, and it's set to automatic startup. We've now set up some examples of enhanced logging on Web01, APO1 and APO2. This will help with our monitoring of access attempts and attack activity. We have a running seam in which Kibana and Elasticsearch communicate across HTTP. If we believe there's a risk of interception, then we can reconfigure ElkStack to use HTTPS. This isn't necessary for the workshop environment, but it's good practice in production environments. The first thing we need to do is to create the root certificate and the Kibana certificate that we need. So we'll run this as root sudo su, and we run user share Elasticsearch bin Elasticsearch dash cert util CA for our certificate authority. And we'll take the default output file and we won't put a password on it. We'll now use this CA certificate to create a Kibana certificate. So again we run cert util, and the cert --CA is our Elastic stack ca.p12 that we've just created, and we'll make the DNS ElkStack, as this is the server that's delivering it, and the output certificate will be kibana-server.p12, and our password is blank, and the password for the Kibana server is blank. Okay, we now have our certificate in a P12 format. So let's use OpenSSL to split it into its public key certificate and private key parts. We do that with OpenSSL, pkcs12, and the input is /user /share /Elasticsearch Kibana server.p12, and the output file we're looking for is /etc/kibana /kibana-server.crt, and we'll put -clcerts -no keys, and we won't have an import password, and we've now got our public key certificate. We'll do the same thing again. This time we'll produce the key file, kibana server.key, and it'll be no certificates and nodes as our parameters. And we now have our private key. We'll set the ownership and permissions on these so that Kibana can access them. So we'll chown root kibana /etc/kibana /kibana-server.crt, and the same for key, and we'll chmod 660 /etc/kibana-server.crt, and the same for the key. So finish preparing our certificates, and we can update the Kibana configuration. nano /etc/kibana/kibana.yaml. We can update our server public base URL to HTTPS. We'll uncomment the server SSL enabled from false to true, and we'll update the certificate and server lines with path to our server CRT, which in our case is etc/kibana/kibana server.crt and etc/kibana server.key. And we'll save that. Okay, we're done. Now let's restart Kibana, remembering that we'll then need to log back into ElkStack with an HTTP session. System control, restart Kibana. Okay, we'll start Firefox again, and we'll now connect on HTTPS to 192.168.1.102.5601. Or we could have used localhost, of course. We'll accept the risk of a self-signed certificate, and we've got our access to Elastic. And we can use our new CyberX account and log in. Okay, we've upgraded our connection to Kibana to HTTPS, and we're good to go. We're at the monitoring screen in ElkStack and have a 15-minute real-time window showing our earlier reconnaissance stage of the attack. Let's now start stage 2. As we watch the display, we start to see a lot of messages for APO1. If we open one, we can see this as an SSH logging event, and we can see it's got a failure outcome. On the second page, we can see the related user is Akhtar. So let's add related user to our display and event outcome. We'll also now set our source IP to our attacker's source to find out what our attacker is doing. So we can now see we have a continuous stream of events with a failure outcome. This is in fact our Hydra attacks against APO1. We've now seen a success in the attack, and we're now seeing some activity against our Gym website with an upload of a PHP file. We can see the PHP file kamehameha.php has been put into the upload. We'll stop our real-time activity and we'll change our filter to be source IP 192.168.1.100, which we found in our reconnaissance to be our attacker. And we'll have a look at process name SSHD and event.outcome success. We have two entries, and we can see that both are successful logins to APO1 by the attacker using the user ID Akhtar. One was from the Hydra scan to test for passwords, and the second was the actual login. We have enhanced SSH logging on APO1, so let's change our search filter to look for SSH activity. And we can simply say message SSH star. We can now see that there was a sequence of commands to establish a superuser account and list the shadow file. We now have evidence that the attack was successful, and we can confirm that we have a problem. While this SSH attack has taken our attention, we might still want to do a check on our web server, given that it was being scanned during the reconnaissance phase, and we saw upload activity during the exploit phase. We'll enter a search query, hostname equals web01, and event category is web. We get a series of logs and we can see they're all successful accesses. We can see from the URL path that many of these are for Nginx status. So let's add and not URL dot path Nginx_status. Now we see we only have 7 hits, and we can see one is an upload. Let's check it out. On page 3, we can see that this is a Python request, and it's uploading something called Kamehameha. We don't know it yet, but we found the exploit that enables remote code execution on our Gym website. Even in this relatively limited scale of test, we can see that ElkStack manages large numbers of logs, and finding attacks is as much about knowing what's normal and what can be filtered out as it is knowing our threats. We've covered the basics of ElkStack, and this is a great start to your path towards your SOC 200 OSDA certification. Now we have a fleet server, we can start adding our hosts. This process is similar to that which we've just done for the fleet server. Let's click Add Agent. We'll select the Linux agent policy. And once again, ElkStack has generated the commands to load this policy into the host. We'll copy them. We'll save this into a file called lagent.sh. We'll again change the folder to lagent, and we'll add the ---- insecure flag. Okay, we'll save this. We need to run this script on the hosts, so let's set up a Python web server so that we can access it from our Web01 and App01 hosts. Python 3 -mhttp.server. We're in our web server root folder, so let's pull down our script. wget http 192.168.1.102, and we're running on port 8000, and we want elegant.sh. And we'll make this executable chmod +x lagent.sh sudo nano lagent.sh, and I forgot to change directory to lagent. And so let's execute it. Okay, we'll come back when this is finished. Okay, that's completed. And when we check our Elastic stack, we find that one agent has been enrolled. We now have Web01 and ElkStack. Let's add another agent for App01. Again, we're going to run the Linux connection, and the generated connection script is the same. We've activated logging from IP tables, so we'll need to add an IP tables integration to the Linux agent policy. Why don't you pause the video for a moment and take the opportunity to do that yourself. We'll add another Linux agent, this time App01, and we'll SSH in from ElkStack. First of all, we'll copy our lagent.sh script, and then we'll SSH using the Ubuntu account at 192.168.1.111. And we'll put in the password of Ubuntu. And we're now in App01, so let's repeat that installation that we did for Web01. We'll set up a root session and go into root. We can now just nano lagent.sh and paste it and make it executable and execute it. Okay, and we'll come back when this is finished. We're complete again, and back in Elk Stack we have 3 agents. The process for installing an Elastic agent in Windows is essentially the same. We again add agent, but this time we select Windows. We'll switch tabs to the Windows enrollment script, which is in PowerShell, and we'll copy it, and we'll save that nano lagent.ps1, and we'll paste it, and we'll make the same couple of adjustments as we did for the Linux one. We'll change the folder name, rename item, minus name, Elastic Agent 891, etc., minus new name, lagent, and we'll change directory to lagent, and we'll add minus minus insecure. Okay. We'll now run the web server again. Python 3 -m h ttp.server. And in apo2 we'll open up an administrative PowerShell and we'll download the script wget http 192.168.1.102 on port 8000, and the script is lagent.ps1, and we want to call the output lagent.ps1. Okay, we can now run it, lagent.ps1, and this will run silently. And the installation has been successful, and when we check back in Elk Stack, we see that an agent's been enrolled. And we have all our agents. We're still using the original installation name for the Windows host, so while we're here, we might go to the Windows host and rename this PC to apo2. And we'll restart. And Elk Stack picks up the change of name on the Windows system. One of the major tasks in cyber defense is monitoring for attacks. In this section, we'll check out what is known as a Security Information and Event Manager, or SIEM, which we use for centralized monitoring of logs. The first of 2 security information and event managers that we'll look at is a tool called Elk Stack. The name Elk Stack comes from the 3 original components that make up the SIEM: the Elasticsearch database, the Logstash log management system, and the Kibana user interface. We won't be installing Logstash, as we can collect the logs directly into the Elasticsearch database, but we'll still refer to our SIEM as Elk Stack. The purpose of this system is to collect logs which record events that have happened on a host, and be able to search these logs to find any unusual activity, or to match them against known attack logs so that we can be alerted if an attack is taking place. I've cloned the Kali Purple template and now have the Elk Stack server on 192.168.1.102. So let's install Elk. We start by installing Elasticsearch. Sudo apt install -y Elasticsearch. Elasticsearch is installed, and let's take a note of our password. I'll copy that, and I'll store that elastic.password in the root folder. We'll need to update its configuration by sudo nano /etc /elasticsearch/elasticsearch.yaml. And we'll comment out its cluster statement, and we'll add a statement at the end, discovery.type is single node. Okay, we can save that. We can now load the Kibana component of ElkStack with sudo apt install -y Kibana. We'll need to generate the encryption keys to be used by Kibana and then update its configuration file. We'll run sudo /user/share Kibana bin Kibana encryption keys, and we'll request to generate -q. Okay, that's our encryption keys. Let's copy them. And we'll sudo nano /etc/kibana/kibana.yaml to update our configuration. We'll set our host address to server host 192.168.1.102. And we'll change the server public base URL to http://192.168.1.102:5601, which is the port we'll be connecting on. And we'll come back in due course to change this to HTTPS, but this is fine for the moment. And at the bottom, we'll paste in the encryption keys. Okay, we can save that. We can now enable and start the two ElkStack components. Sudo system control enable Elasticsearch Kibana and run them immediately. Let's check the status of Kibana. System control status Kibana. We're active, and let's take a note of the code at the bottom of the display, which we'll need to use shortly. 623116. Now we've got the ElkStack components running, we need to connect Kibana to Elasticsearch. We do this by creating an enrollment token. Sudo /user/share/ Elasticsearch /bin /Elasticsearch -create -enrollment token, and we want a Kibana token. Okay, let's copy this token and let's open Firefox. We'll go to http://192.168.1.102:5601, which is our portal address for ElkStack, and we'll put code equals 623116 for the first time we go in. And we need to paste our enrollment token, which we do, and then configure Elastic. Okay, we're set up now. We can log in with the default account, which is Elastic And we need the password that was generated when we installed Elasticsearch. We stored that, so let's retrieve it. And sudo cat /root/elastic password. And we'll copy that and paste it and log in. We're encouraged to load an integration, but for the moment, let's explore on our own. Okay, in the left-hand main menu, we'll scroll down to Management, Stack Management, and we'll scroll down to Users under Security. And we'll create a new user. We'll call the username CyberX, and we won't bother with the full name and email address. We'll call this CyberX as the password. We'll confirm the password. And in the role, we'll select the role of superuser. And we'll create the user. Okay, we now have a user that we can log in as without using Elastic. We've now set up an operational SIEM and have a manageable set of credentials to use. Depending on how we're performing, we can adjust the memory and cores that we use for ElkStack. I've upped the memory to 8 GB and left it with 1 core, and that seems to be pretty comfortable. One of the more powerful monitoring capabilities in ElkStack is alerts. From the home page, we can select Security Alerts, and at the top right, we can manage rules. If we haven't loaded the predefined rules yet, we'll be asked whether we want to import them, which we will. And we'll install them all. We now have over 800 pre-built rules installed, each of which can be enabled or disabled using the switch at the right of the alert. Let's search for SSH. And we'll take a look at the rule Potential SSH Password Guessing. In the right-hand pane, we're provided with a description of the alert and also its coding within the MITRE ATT&CK framework. In the right-hand pane, we can see the query. In this case, we can see that the query is looking for a time span of 3 seconds and that it's looking for 10 attempts. Also note that this is focused on Linux hosts. We'd have to write a different query to check for brute force attacks against a Windows SSH system. In the lower right-hand pane, we can see that this alert will run every 5 minutes. While it will cover any attacks in that time, we do have some delay in the alert being raised. Okay, let's enable the alert. Now let's go to the dashboards and select Detection and Response. We'll set the time span for the last 15 minutes. And we'll refresh every 10 seconds. We currently have no alerts to display. We're in Kali and we'll run a Hydra attack against our APO1 target. We'll go into our autopilot folder and we'll run Hydra -L actar -p pass.txt, and we'll be looking at an attack against SSH 192.168.1.111, and we're attacking. Now let's go back to monitor our alerts. Our dashboard is updating every 10 seconds, but we still have no alerts raised, although the attack has started. We now see that 12 alerts have been opened, and that they're all listed under the one potential SSH password guessing rule. When we check the Users by Alert severity panel, we can see it's the Actar account that's the cause. Let's click on the account number, the 12, and we get details of the alert. At the bottom left, we have 3 icons for viewing the details. Investigating in the timeline, which shows the logs on a timeline and is useful when we have a number of events which might show the stages of an attack. And More Actions. Under More Actions, we can now make this alert into a case to be investigated. So we'll add it to a new case. We'll call the new case Brutish. We'll set its severity to medium, and we'll give it a description: brute force attack on APO1 Actar account. And we'll create the case. And now back at our main detection and response dashboard, we have 12 open alerts and 1 open case. Wazoo started life as another elastic Kibana solution for log collection and monitoring, but has evolved into its own platform based on OpenSearch. It comes as 3 components: the indexer, the server, and the dashboard. I've cloned a Wazoo platform from the Kali Purple template, so let's start by making a folder for Wazoo. Make the Wazoo cd Wazoo, and we'll need to get the Wazoo installer and configuration file, which we can do using wget https packages.wazoo.com 4.4 wazoo install.sh and config.yaml. We'll switch to privilege mode for the rest of the installation. Sudo su. Okay, let's make the installer executable. Chmod +x wazoo install.sh, and we need to update the configuration with our own IP address. Nano config.yaml 192.168.1.103, and all 3 components are on the same virtual machine, so we use the same address for all of them: 192.168.1.103, 192.168.1.103, and we'll use these default names when we do the installation. Okay, we'll now use the installation script to generate a configuration tarball which Wazoo needs. We'll use the -I switch to suppress hardware and software verification. Wazoo install.sh with the -I switch, and the first thing we do is generate the config files, which is the tarball. Okay, we can now see that our config file has now changed into our installation tarball. The next thing we'll do is create the indexer component of Wazoo, again using the Wazoo install script with the command wazoo indexer, and our default index name from our configuration file is node1. This is going to install any packages that it needs and then proceed to build the indexer. It takes a fair bit of time, so we'll be patient and we'll let it run. After completing the installation of the indexer, we now need to start what's known as the cluster. So we'll run the installation script again with the command start cluster. Okay, we'll now install the second component of Wazoo, which is the server. Run the installation script again with the command wazoo server and the server name, which is the default wazoo1. Okay, that's installed, so the final step now is to activate the dashboard. And again, we do that through the installation script with the command wazoo dashboard and the dashboard name, which is just dashboard. Okay, that installs and starts the dashboard service and provides details of our access credentials. We'll copy the password and we'll browse to https 192.168.1.103, or we could have done localhost. We'll accept the risk and continue, and Wazoo starts up. And we can use admin and the password we've just copied and log in. Wazoo runs a series of health checks and then presents its main screen. Okay, the first thing we'll do using the menu is to go to Security, Internal Users, and create an internal user. We'll set up a user called Cybex, and we'll use a password WZH Cybex. WZH Cybex. And we'll enter admin as the backend role and create. Okay, that's the server setup complete. To get the most value out of Wazoo, we'll want to customize both the configuration and the rules files. We're on Web 01, our Nginx server, so let's take a look at the Wazoo agent configuration. You can do that with sudo nano var ossec etc ossec.conf. The first thing to note is that we have the server address details, shown here as 192.168.1.103, and the collection port of 1514. There's also some connectivity settings, and following this, the client buffer settings. Following the policy monitoring heading, we can see the details of Wazoo's root check. This check looks for signs of intrusion on the system being monitored, and we can see the location of Wazoo's rootkit and Trojan's signature files. Following this, we find the specification for the CIS audit check, which shows how well the system meets the hardening guidelines published by the Center for Internet Security. Let's get past the various system monitoring sections and get down to the start of the second OSSEC configuration section. Here we find the log files that are being collected. The first two specifications are for the Nginx access and error log files. Wazoo was smart enough to detect that this was an Nginx system and automatically included the Nginx log files. Following these is the Wazoo active response and DPKG log files. If we want to collect any additional logs, we can add further location clauses here. We don't currently collect any Suricata Eve logs, so let's add that. Local file, log format, and the Eve logs are in JSON format, /log format, and their location is /var/log/suricata/eve.json and /location /local file. And so now we'll be collecting our Suricata Eve files. And we'll save that. And then we'll sudo system control restart the Wazoo agent to activate the new configuration. To look at the Wazoo rules, we need to be on the server in a privileged terminal. The standard rule set is stored in the folder ls/var/ossec/ruleset, and it has the decoders, rules, and the security audit specifications. And if we have a look at what rules we have, we can see there's a fair amount. So let's go into that folder. And let's take a look at the Suricata rules that will be used to process the Eve logs we've just configured. Nano 0475 Suricata _ rules.xml. We can see the expected log format in the form of an example starting with a timestamp, then flow ID, and so on. This is followed by 5 rules with identifiers 86600 to 86604. If we look at rule 86602, we can see it's an HTTP event being reported by Suricata. If the event type is matched, then the log will be forwarded to the analysis and monitoring system. These rules are updated every time we update Wazoo. Let's see what happens when Wazoo receives a log. We can do this using the log test tool. We'll go to var ossec bin /wazoo log test. And we're invited to enter a log. Let's put one in. This is just an example of what an invalid user log would look like from SSH. We get the results of the 3 phases of event processing. The first is the pre-decoding, which extracted the timestamp, hostname, and program name. The second extracted more fields, including the username and source IP address. The final phase is the rule analysis, which shows a match against the rule number 5710 to the MITRE technique of password guessing. Wazoo would raise an alert for this log and pass it on to the monitoring and alerts screens. Let's run our workshop attack again, and this time monitor the activity with Wazoo. We're at the Wazoo detection screen with our monitoring set to show 15 minutes of activity and to refresh every 10 seconds. We do have some alerts showing, but these relate to routine activity on APO2, which is advised due to the possibility that it may be malicious. At this stage, these are false positive alerts. We've got our learning.py script running in our Kali attack VM. So let's open a browser tab and check out our attack. http 192.168.1.100/check. And we're asked to enter our offsec credentials. And we can see the attack is at stage 0 of 3. Okay, let's start the attack. And we'll set the mutex to -2. And then go back and watch the Wazoo screen. The expression -2 means run the attack through to and including stage 2, which in our case means we'll run the whole attack. We'll wait for a few seconds to let the attack stage 1 start. Okay, we're starting to see a number of alerts pop up for both APO1 and WebO1. But at this stage we haven't matched to any MITRE attacks. Now we've got a couple of thousand alerts popped up, and these are primarily vulnerability scanning alerts. Most of the activity at this stage is occurring on WebO1. We've now got a number of authentication failures popping up. Quite a lot of authentication failures popping up. And at the right, in the MITRE graphic, we can see the various types of alerts that are happening, with vulnerability scanning, brute force, password guessing, and so on. In the top 5 agent graphic, we're seeing an increasing level of alerts occurring on APO1 now. We're now starting to see some successful authentication attempts. We're continuing to get authentication failures, but we're getting a few more authentication successes. We've now got a level 12 alert, which is essentially a serious attack detection. We'll stop the ongoing refreshing, And without doing much further work, we've seen a reasonable overview of the attack, starting with scanning and then SSH brute force attacks, which eventually succeeded. If we scroll down to the alert listing at the bottom of the screen, we can see the individual alerts. If we click on Level, we can see the 2 Level 12 alerts. And these are both multiple authentication failures followed by a success. We can see there's a lot of failed Web 400 accesses with almost 300 pages of alerts to review. This is better than reviewing logs, but there's still a lot of noise. If we scroll back up in the MITRE graphic, we can see there's a process injection category. If we click on that segment, and then scroll down, we can see the alerts that have been filtered to just these 5 events. However, when we look at them, they are just part of the scan. What we don't see as an obvious call out is a PHP attack on the gym website. Okay, let's go back to the full set of attacks and go to the events screen and search for PHP. And we can see we've just got one warning message. If the exploit doesn't trigger a Wazoo alert, then it won't appear in the Wazoo events. The gym exploit managed to escape detection. Now we have the Wazoo server operational, we can monitor hosts which have a Wazoo agent installed. Let's install one in our Web01 web server. The first thing we need to do is download the GPG key for Wazoo and update our sources. And we'll do this in an admin session. I've put the commands into a small script for convenience. Sudo su, and the scripts are called wagent.sh. And we're just curling the GPG down into our web server and updating our repository lists. Let's run this. Wagent.sh. Okay, we can now point to the Wazoo server and install the agent. Wazoo manager equals 192.168.1.103 apt install Wazoo agent. Okay, we've installed the Wazoo agent. Let's just check the configuration file by nano /var /ossec /etc /ossec.conf. And we can see our IP address is 103. We now need to enable the Wazoo agent to start on boot, and we'll do that with system control daemon reload and then system control enable Wazoo agent, and we'll start it now. Okay, that's running, so let's go back to our Wazoo server and we'll refresh, and we can see that we're now monitoring one agent. We'll use the drop down to go to the agent screen, and we can see Web01 is active. Back on our main dashboard, one of the important areas for us to focus is the Security Information Management pane, and in particular on the Security Events tile. Here we see the security alerts that have been generated from the Wazoo alert signatures. We can also monitor logs using the Discover menu item. We're presented with the familiar monitoring screen that we used in ElkStack. Let's enter a search for agent.name web01. And here we can see the logs we're collecting from our web server. The search language we use in Wazoo is DQL, the OpenSearch dashboard query language. Okay, we now have a fully active agent enrolled. Installing the Wazoo agent in App01 is the same process as for Web01. We've enrolled both Web01 and App01, so let's now enroll our Windows server, App02. Let's use PowerShell to download the agent. We can use wget for this. And we're downloading agent 4.5.1-1. Okay, and now let's install it. Wazoo agent 4.5.1-1.msi, and we'll set Wazoo manager equal to 192.168.1.103. Okay, we'll accept the terms and install it. And we'll finish. And if we check our services, we can see we now have a Wazoo service that's set to automatic start. And it's not running at the moment, so let's start it. Back in our Wazoo console, we can see we have one new connected agent, and if we refresh, we have 3 active agents. Often an attack will upload and then use a web shell as its foothold into our system. Web shells are difficult to detect as they're easily modified by attackers and can use encryption, encoding, and obfuscation to change their signature. Let's look at the basics of a web shell. I've installed one in the web root. Let's have a look at it. This is a simple shell which outputs a text box for us to input a command and then executes the command. Let's do that. We'll go to localhost /shelly.php and we'll enter who am I and execute it. And we get the answer www.data. We'll come back to this, but now let's install the Audit D tool to provide enhanced logging so that we can improve our detection of web shells. And we do that with sudo apt install Audit D. Audit D by default doesn't check for execution of web shell commands, but we'll create a rule for this by checking for any command which is executed under the www.data account. We'll need to check the unique identifier of www.data to do this. So let's find that. We can get the details of it by saying id www-data. And its UID is 33. There's a couple of steps to getting a rule activated, and the first is to create the audit log. For this, we'll add an additional audit rule to Audit D. Sudo nano /etc/rules.d/audit.rules. Okay, and we'll add set web shell rules -a exit, comma, always, -f arch equals b64 -f uid equals 33, and these are the fields we're checking, -s exec ve, and what we're going to do on the audit record is put out web shell command exec. Okay, so we're always going to create an audit log when there's a command execution and the unique identifier is 33. We'll put a message in the log so that Wazoo can alert on it, and the message text is web shell command exec. Okay, we'll save this and we'll restart Audit D. Sudo system control restart Audit D. The next thing we need to do is make sure that the Wazoo agent will collect the logs that auditd creates. We can do that by adding another new log location into the Wazoo configuration file. Sudo nano /var /ossec /etc /ossec.conf. And down at the bottom in our ossec config section, after our suricata logs, we'll put local file log format audit /log format location /var /log /audit /audit.log /location and /local file. And that's pretty self-explanatory. Okay, so we'll save that and we'll restart sudo system control restart our Wazoo agent. We've made sure that the log record will be passed on to the Wazoo monitoring system, but this won't in itself cause an alert to be raised. Let's make sure we raise this as an alert by adding an alerting rule. We do this by editing Wazoo's local rules file. I've already set this up, but let's take a look. Sudo nano var ossec etc rules local rules.xml. We're giving this a group name and a rule number, and we can make these whatever we want as long as they're unique. Normally, we'd make the rule number greater than 100,000 to distinguish it from Wazoo's built-in rules. The trigger for this rule to raise an alert is finding the text web shell command exec in the key field of the audit log record. The description is what will appear in the alert, in addition to the full log record contents. We're also flagging the relevant MITRE attack techniques, which relate to this particular attack. Okay, let's restart the Wazoo manager. Okay, let's start up the Wazoo monitoring console. We'll go to security events, and we'll select the events, and we'll set the last 15 minutes with a 10-second refresh. We've got some benign alerts coming through that we can ignore, but let's navigate to our simple shell and run a command. http 192.168.1.110/shelly.php. And we get our command execution box, and we can, for instance, execute cat /etc/password. Back in our monitoring screen, we now see some possible web shell exploitation alerts. And we can see /etc/password. We'll stop the real-time display, and we can see the web shell command exec record, and we can see user bin cat executed against /etc/password. Wazoo is a powerful alerting system which comes with a significant library of predefined alerts. And as we find new attacks that we need to alert on, it's simple enough to add our own definitions to Wazoo. Vulnerability scanning isn't enabled by default in Wazoo. And if we select an agent, APO1, and have a look, we can see there's no results, and no scans have been run. Let's activate the targets we want scanned. We can do this in the vulnerability detector portion of the main configuration. Sudo nano /var ossec/etc/ossec.conf. And if we go down to the vulnerability scanning section, the vulnerability detector is currently not enabled, so we'll enable that, and we'll enable scanning on Ubuntu and Debian systems, and Windows is already enabled. Okay, we'll now sudo system control restart Wazoo Manager. Back in the portal, we'll refresh, and we find there's no change. Wazoo is currently downloading the vulnerability definitions, and once complete, we'll run a scan. Okay, we're back now, and Wazoo has completed its update and run its first scan. We can see on app01 that we have plenty of vulnerabilities to check. If we click on the 23 critical vulnerabilities, the list at the bottom is filtered to just the critical issues. If we select the top line, we get more details, and at the bottom of the detail pane, we see the vulnerability alert shown as an entry in OpenSearch. If we expand this and scroll down, we see that the field Data Vulnerability Severity is where we find the rating critical. If we now go to the Discover screen, we can search for all critical vulnerabilities with the expression Data Vulnerability Severity Critical, and update. And we see we have 100 critical issues to resolve. We can select the three fields, agent name, data vulnerability CVE, and perhaps data vulnerability rationale. Okay, we've now got a great search that we can save as criticalities. And we can come back to this at any time that we want to see our list of up-to-date critical issues. Cyberville is a simulated cyber attack exercise created for the 2020 SANS ICS Virtual Conference Capture the Flag event, and the associated log capture has been made available for use. The Cyberville PCAP file is available in your exercise folder, and I've already copied it into the Malcolm VM, so let's upload it into the Malcolm system and take a look at the attack. We can select Applications, Internet, Malcolm, Upload, and enter our credentials. And we get the PCAP upload screen. We'll select Add Files, and we'll add the Cyberville PCAP. This now appears in the list of files to import. This PCAP file will be given the default tag Cyberville. We can add more tags to all the logs at this stage if we wanted, but we don't, so we'll leave this blank. We'll check Analyze with Suricata and Analyze with Zeek, but we don't need to extract Zeek analysis to an external file, so we'll leave this blank as well, and we'll start the upload. Okay, that's done. Let's now go directly to our dashboards on https 192.168.1.116/dashboards. And we'll accept the risk, and enter our credentials again and sign in. The OpenSearch dashboards provide a wide range of predefined analyses of the session and packet data. From the menu at the left, we can select Visualize, and we see the range of existing visualizations provided in the Malcolm tool, and we can create our own. We're currently showing no data, but note that at the right of the search bar, we're requesting logs for the last 15 minutes. For Cyberville, we know the event took place on the evening of 28th of April 2020, so we want to change our date range to that day. So we'll select Absolute Year 2020, month April, day 28, and we'll have as our start date 1730. For the end date, Absolute 2020, April 28, and as the end date, we'll select 11 p.m. and we'll update. Okay, we now have an event of 150,000 or so Zeek logs and 785 Suricata alerts. We can see the log collection started around about 7 p.m. and concluded around about 9:30 p.m. Below the top two diagrams, we have some tables showing analysis of the event by log type, by application protocol, and by actions and results. Below these, we have a connections by destination country graphic and a DNS queries table. And at the bottom, we have a table of all logs in the event. This screen is all Zeek logs, and if we expand the first one, we can get the full log details. Back at the top on the left, we have the dashboard's menu. We're currently at the overview screen. If we select Security Overview, we find our Suricata Alerts dashboard. This is showing a range of different issues, including 42 MITRE attack technique alerts, malformed traffic, privacy violations, and suspicious file names. We see 3 sessions flagged as Eternal Safety. This is a Zeek package for detecting dangerous violations of the SMB version 1 protocol. Amongst other violations, this package can detect attacks which attempt to use the various exploits in the Eternal family: Eternal Blue, Eternal Synergy, Eternal Romance, and so on. Back in the left-hand menu, Malcolm also provides visibility into files being transferred, executables appearing in the logs, and software being used. To finish our initial tour of Malcolm, we'll open the Alchemy Viewer, which is in the home page, https:192.168.1.116. We'll set our dates again. Okay, we can now see our Alchemy logs for the event. The main portal is where we can search and investigate session data. We can set the histogram display to show sessions, packets, bytes, and data bytes. Below the histogram, we have the individual session entries. By clicking on Data Source, we can switch between Zeek and Alchemy logs. If we open one of the logs, we'll get the full session details. Okay, we'll leave the tour now and get down to the task of hunting for the attack. As part of the release of Kali Purple, the Malcolm tool, developed by the Idaho Labs for the US Department of Homeland Security, has been forked into a Kali Purple friendly form. This tool provides an integrated set of tools for traffic analysis to support threat hunting. It consists of the Suricata IDS, the Zeek Session Analysis tool, and the Alchemy Deep Packet Inspection tool, all feeding into an OpenSearch database. The pipeline diagram shows the main components of the Malcolm system. While it can run live, we'll be using Malcolm in its offline form, where it consumes a PCAP for file analysis. When we import the PCAP file into Malcolm, it's automatically analyzed by Suricata and can optionally be analyzed by either or both of the Alchemy Deep Packet Capture tool and the Zeek Session Analysis tool. The packets are stored directly in OpenSearch, and the results of the Zeek and Suricata analysis are stored in Logstash for ingestion by OpenSearch. The Alchemy Viewer can be used to access OpenSearch for packet and session searching, and to access the predefined dashboards in Malcolm. During packet ingestion, Malcolm enriches the raw packet data with additional information including IP locations, hardware manufacturer information, and host and subnet names. We're at the dashboard portal in Malcolm with the Cyberville event data loaded and the date set to bracket the event. When we're going on a threat hunt, the Security Overview dashboard is a good place to start. At the right is the first of two panels of Suricata alerts. Let's filter on the PowerShell alert by clicking on the plus symbol. And this filters the display down to just one event. Let's scroll down to the bottom of the screen to see the event log. We see it's from 10.10.10.11 to 10.10.10.3. And we can expand this event, and we can see it shows a file source of HTTP and a file path of post-exploitation session gopher PS1. And if we scroll down to the rule name, we can see that it's a PowerShell base64 decode. This is definitely malicious. Now let's select HTTP under Common Protocols, and we get the HTTP dashboard. If we scroll down, we can see the different kind of user agents that have been detected. There are two which stand out as potential attack indicators: the Mozilla 5 Nmap scripting engine, which definitely indicates a scanning attack, and the Python URL lib 2.7, which indicates access from a Python script. Let's go back to the security overview and scroll down. And at the right, we can see a panel headed Clear Text Transmission of Passwords, and it's showing a single account log plus in having occurred 15 times, all within HTTP sessions. While we can't get any more details here, we can use OpenSearch to look at the HTTP logs. To do that, we click on the hamburger and select Discover. Okay, let's do a search for the string log plus in. And we have 29 results. We'll select some fields to display to get a better view of what we're seeing. We'll select user, URL password, and HTTP request body. We've now got a nice display of the passwords being used. And we can see that the requests are for root and a user called username, and passwords which look like legitimate complex passwords, the word password, and some hacker-style passwords used on both. If we check the first entry, we find the destination geo country name is United States, and the source geo country name is Canada. When we check the third, we find the destination geo country name is again the United States, but the source geo country name is Russia. Let's go back to Security Overview and select Zeek Notices from the left-hand menu. These are Zeek's equivalent of alerts, where the session data indicates potential malicious activity. We can see that Zeek has identified in its Notices table what it considers to be discovery, lateral movement, execution, and port scanning events. And at the top right has also flagged both Eternal Safety and Ripple 20 category events. Ripple 20 is a family of exploits against the TREC embedded IP stack used in industrial control systems. If we scroll down to the logs at the bottom of the screen, we can see the logs that Zeek has flagged in its notices. Here we see the various malicious activity events relating to TREC devices and writing admin $psexec svc.exe, pivot.exe, and beacon.exe into various shares. Let's now select Files. If we go to the second page of the MIME types, we find the bottom entry is for one Python file. And if we click on the plus, we'll filter to just the one event. And then if we scroll to the bottom and open the event, and we find that the Python script detected is called icebreaker master icebreaker.py. Our research indicates that this is a hacking tool to get plaintext Active Directory credentials if you're on the internal network but outside the AD environment. Let's go back to the list of files, and on the second page, select the text MS-DOS batch type file. We can see that the file source is HTTP, but we don't have any details on it. So let's scroll back up, click on the icon to the left of the filter expression, and select Pin All. And that will keep our filter. We can now select the Common Protocol HTTP, and just this one entry will be shown. When we scroll to the bottom, we can see the URL is the folder post-exploitation winpeas, and the batch file is winpeas.bat. Winpeas is a commonly used enumeration tool for finding Windows privilege escalations. We've got a pretty good idea now from our dashboards that we've been compromised, and we've started to understand the activities involved in the event. From our Malcolm dashboards, we've been able to collect fairly convincing evidence that we've been under attack. We'll now switch to Alchemy and deep dive some of this activity. To start with, we'll select the SPI graph view. This by default shows protocol use and destination. And at the right-hand side, we can open the map view. We can see the complete logs at the top, and then each protocol with its logs in bands below that. We can see from the top that there's been activity to and from Russia. And if we scroll down, we can see from the shading that this occurs for TCP, HTTP, SSL, TLS, ICMP, and SMB interactions. We can select different SPI graph views. If we click on Protocols and select instead User Agent Original, we now have an analysis by user agent. And if we scroll down, we'll find that the Python user agent was used for interactions with Russia. Let's now look at the connections view. This just shows a couple of IP addresses. However, at the top left we can see by default this is just 100 events. So let's set our filters and then increase it. Firstly, using the top right icon, we'll select Zeek conlogs. And from the query size, we'll take the maximum of 100,000. We can now see all the interactions that have taken place. We can adjust the dest field, for example, by selecting Service. And this then shows the services being used by each of the IP addresses. By understanding what's normal, we can get an idea of what's malicious lateral movement. Let's go back to the Alchemy home screen and search for significant size HTTP packets, which might indicate infiltration of tools or exfiltration of data. In the search box, we'll enter protocols equal HTTP and data bytes greater than, say, 8,000, and search. We've got quite a few results, and scanning down the right-hand side, we can see PHP files, psattack.exe, Mimikatz, PowerShell scripts, and so on. The timeline of tool infiltration provides a good indication of the progress of the attack. Let's take out the data size and replace that with a search for PowerShell files. So we'll search for protocols equals HTTP and http.uri equals star.ps1 star and search. Okay, we have some PowerShell scripts. Let's scroll down and look at the Alchemy entry for the domain password spray.ps1 script. If we expand the session contents, we can scroll down the page. And on the right-hand side, we get the full PowerShell script. Just prior to the script, we can see that this has been downloaded from a Python simple HTTP server, and that this is the standard DaftHack Active Directory Password Spray tool. As a threat hunter, we'd now start to arrange the activities we've found in chronological order and determine the specific breach points and internal vulnerabilities. We won't spend any more time here, but from this exercise, we've been able to learn the basics of using Malcolm. Malcolm is provided as a Kali Purple-based ISO image, which we have to install. It's a fairly resource-intensive system, so requires 2 CPU cores and 16 GB of RAM. Installing Malcolm is essentially the same process as for Kali Purple. I've prepared a VM, which I've called Malcolm, using the ISO image. And I'm at the home page in Malcolm. We have our normal application menu at the top left, and in particular, if we select Internet, we see the various components for Malcolm. The Alchemy and OpenSearch dashboards are the 2 key components we'll be using. We also have a top ribbon with quick links to some of the tools. The Alchemy icon is the link to the Alchemy screen, and the blue squares to the OpenSearch dashboards. Let's select the yellow icon, which is Start Malcolm. We have some initial questions to answer, and we'll be taking the default settings for them. We'll store an administrator username and password for local Malcolm access, and we'll enter, again, Malcolm with a password of Malcolm. We'll regenerate self-signed certificates for HTTP access, and we need to wait at the Regenerate Certificate screens for the certificates to be generated, as this needs to generate multiple certificates for the Malcolm components. And we generate certificates for the remote log forwarder, and we won't store a username and password for the primary remote OpenSearch instance, nor for the email alert sender, but we will generate internal passwords for Netbox. So this question stays on the screen for a while, but in the background, Malcolm is pulling down the 20 or so Docker images it needs to operate. This takes quite a while, and during this time there's no visible sign of anything happening. The system hasn't frozen, it's just busy. We'll be patient and wait for the images to be loaded. Once we have the images loaded, the Malcolm startup proper is displayed in the terminal. This ends with the messages, OpenSearch is up and healthy at HTTP OpenSearch 9200. And finally, OpenSearch dashboards, saved objects, import complete. Cyber threat intelligence is an important source of information for a security operations center. It can be provided as an automated operational data feed into detection systems such as firewalls and IDS. And it can come in the form of strategic reports on adversaries, their campaigns, and the techniques and malware tools they use. The MITRE ATT&CK site is one of the main information sources which we can browse for threat intelligence, and we've seen tools like Wazoo referring to it in their detection reporting. With cyber attacks occurring both at speed and at scale, threat intelligence is at its most useful as soon as it's created. By acting on threat intelligence at the earliest possible time, we have the maximum chance of preventing an attack, rather than having to recover from one. For this reason, national authorities, typically the Central Computer Emergency Response Teams, have encouraged the use of information sharing. This has resulted in the development of a standard notation for threat information known as the Structured Threat Information Expression, or STIX, and the Trusted Automated Exchange of Intelligence Information, TAXI. Together, these are referred to as a STIX TAXI system. The STIX TAXI system consists of two components: the STIX client, which we can use to create and submit threat intelligence, and with which we can receive threat reports from other subscribers. The TAXI component comes as a server which stores and forwards threat intelligence. The folks at Eclectic have developed a Python-based TAXI server called OpenTaxi, and this is supported by Kali Purple. In the next couple of videos, we'll look at how we install and use OpenTaxi. OpenCTI is a popular database system for storing cyber threat intelligence. I've prepared an OpenCTI platform from the Kali Purple template and will install OpenCTI. This is another fairly resource-intensive system, so I've updated the VM to use 16 GB of RAM and 2 cores. OpenCTI is provided as a set of Docker images, and it's most easily installed using the Portainer system. That means we'll have a 3-stage installation: Docker, Portainer, and then OpenCTI. Let's get started with the install. First of all, we'll install Docker. Sudo apt install docker.io. We'll confirm that. And we'll enable it to start on boot. Sudo system control enable docker and we'll start it up now as well. Okay, we'll add ourselves to the Docker group, sudo usermod -ag docker Kali, and we'll set the access sudo chmod 666/var/run/docker.sock. Okay, that's Docker installed. Next, we'll install Portainer, the Docker container management system. Docker volume create Portainer data. So created a Portainer data image in Docker, and we'll now docker run -d -p, and we're going to take ports 18,000 from the Portainer image and map them to ports 9443, 9443 on our system. -name, -name, Portainer, - restart equals always, -v/var/run/docker.sock :/var/run/docker.sock -v Portainer _data :/data Portainer /Portainer-ce :latest. Okay, so we'll install that. And Docker's now pulling down the Portainer images, and once they've been pulled down, it will start up Portainer. Okay, we now have a Portainer running in Docker, so the next thing we'll do is install OpenCTI using Portainer. We'll firstly need to copy the container description, which is provided in the OpenCTI platform page here, and we can copy that, the raw data file, and then we'll need to open our Portainer system, which we can open as https://192.168.1.118.9443. Connect and accept the risk. We need to use a password. We'll put in our password, which has to be 12 characters long, and create the user. So we'll now get started and connect to local and connect stacks from the left. And we'll add a new stack, and we'll call this OpenCTI, and we'll use the web editor to paste in the YAML script. This stack definition requires that we create a number of environment variables and provide them with unique identifiers. To do this, we'll run a small bash script to create them. The script is in your exercise file. We'll firstly sudo make the /opt/opencti, and then we'll run our vars.sh file, and that will create a set of variable definitions that we need to copy, and at environment variables select advanced mode and paste them in. And if we go down a little bit further, we can now deploy the stack. And we now have our OpenCTI stack running. The folks at Eclectic provide a Python library called Cabby for interacting with the OpenTaxi server. There's plenty of examples of how we can use the Cabby library in our Python program. We'll be connecting remotely from our Kali workstation, so let's go there and install it. And we install it with sudo pip3 install Cabby. The installation includes not only the Python library for us to code up our client system, but it also provides a number of command line tools to access the OpenTaxi server. Let's use one to verify we're working by listing out the Discovery 1 advertised services. /user /local /bin, and we have a tool called Taxi Discovery, and the path is http 192.168.1.115 port 9000, and we'll be going to services discovery. Just correct that. And we can see that we're able to interact with the OpenTaxi server. Let's now look at how we might create our own STIX reports. There's a number of commercial STIX clients and a number of sites dedicated to developing STIX clients. The STIX project site has a Python STIX project which provides the necessary library routines to create XML-based STIX tools. Before we can do anything with these examples, we need to install the prerequisite libraries. Let's do that. Sudo apt install Python 3 dev lib xml2 dev lib xslt dev and zlib1g dev. Okay, now let's install our STIX system. Sudo pip3 install STIX. Okay, let's open the STIX project and go into the Python STIX folder, and we'll look at examples. And we'll pick an example of generating a vulnerable software STIX report. So we'll copy the raw file and nano softrep.py and paste the clipboard. And we have to make one small adjustment at the bottom of the file to include the Python 3 brackets in the print statement. So we'll just update this print statement with the correct brackets and save it. Now when we run this code, Python 3 softrep.py, we get a properly formatted STIX package that we can submit as a report on a vulnerability we've discovered in our foobar version 3 software. At the start, we have the STIX header defining this as an exploit target, followed by the details of the vulnerability. We'll not go into the details of STIX reports, however there's a lot of information in the STIX project repository to help understand STIX formatting. Okay, let's save our STIX report, and we'll use a Cabby program to submit it into the Taxi server. So first of all, we'll save this to foobar.stx. We have our STIX report in a file called foobar.stx. So let's look at a short Python script which takes the file and uses Cabby to submit the STIX report to our Taxi threat collection. nanosubmit.py. We start by importing the library functions we need, including the Cabby function to create a client and submit a report. We define our binding and then request credentials and open a client session using them. We get the list of services so that we can select the inbox to which we'll send our report. Following this, we construct what's known as a taxi bundle, into which we place our STIX report using a randomly generated bundle number. We then call the Cabby push function to submit this to Taxi. We're encoding our report in base 64 in order to embed it in the message. Okay, let's run this now. And we'll use Python 3 submit.py to run the script with foobar.sticks as our argument. And we'll enter admin as our credentials, and we'll select the government SIP endpoint. And the report's been submitted. We've now got OpenCTI loaded and can connect using HTTP on port 8080. And we log in with the user ID admin at opencti.io, which is the default in the YAML file, and our password that we set. And we sign in. We're at the main screen for OpenCTI, and we can see we have no entities loaded. To start connecting threat intelligence sources, we need to go to our Portainer console. We've logged into Portainer, so we can connect to local, stacks, and OpenCTI. To connect a threat intelligence source, we need to add its container definition to our configuration. So we'll click Editor and scroll down to the bottom of the configuration. We need to add some source YAML definitions in here. A handy source for these is the OpenCTI connectors page. Let's start with the OpenCTI connector. We'll open the external import folder, external import, and scroll down to OpenCTI. And we'll find a Docker Compose YAML file. And if we open that, we've got the definition that we need for our connector. We'll copy from connector OpenCTI down, and we'll go to our Portainer, and we'll paste that. We need to make sure that the connector line is correctly lined up with the previous connector. We'll take the variable replacement for OpenCTI admin token. We'll copy that and put that into our new definition. We need to change our URL to OpenCTI:8080, as we can see we have in our previous definitions. And we can see we still have a change me for connector ID. The connector ID has to be unique. And we can get a unique ID by going to an online GUID generator and just generating a GUID. Copy it to the clipboard and replacing the placeholder change me. And we'll just update the connector name and just call it OpenCTI. We'll also need to copy the two lines depends on OpenCTI and put those in immediately after the restart line. Okay, so we've now added a connector which will provide us with entities relating to the sectors, the countries or geography, and the companies that we'll be looking at in our threat intelligence. Okay, let's add another one. Back in the OpenCTI connectors, in our external imports, we'll find one called MITRE. And this provides us with the tactics, techniques, and practices of threat actors from the MITRE attack repository. So if we go into Compose YAML, again we have a connector line down that we can copy. We can paste that into our Portainer definition. If we look at just above the definition box, there's an error in the YAML syntax. All collection items must start in the same column. So again, we need to just move connector MITRE over one, and it sorts out the problem. Again, we need to change localhost to opencti:8080. We need to take the variable expansion for the admin token and put that in. We need to get a GUID, so we'll generate another one, copy it to the clipboard and put it in. And we'll change the connector name and just call it MITRE. And again, we'll take the dependency and add that at the end. Note for each of these connectors we're adding, we have a MITRE interval 7 days, OpenCTI interval 7 days. And this is the number of days between updates of the information in those sites. Finally, we'll add the Alien Vault connector. So in our external imports, we can see Alien Vault, and we have the Docker Compose file. There's a little bit more in this one. So let's copy that, and back in our Portainer, put that in before the volumes, and paste it. We'll copy the OpenCTI admin token and change that in the OpenCTI token. We'll get a GUID, copy it to the clipboard and replace the connector ID and paste that. We'll change our localhost to OpenCTI:8080, and we'll copy, as we did before, the depends on lines and add those before volumes. And one thing to note in the Alien Vault definition is we have a line Alien Vault API key is change me. If we want to use this connector, we have to register with Alien Vault and request an API key. This is free to do. If we already have an account with Alien Vault, we can log in, or we can sign up to get one. I've logged into my account, and we can see that we have the option to create or regenerate an OTX key. And we can copy that and use that in our Portainer. And so we'll paste that in where it's requesting the key. Okay, now we've added all three definitions, we can scroll down to the bottom and click Update the Stack. And this will activate the OpenCTI connectors. And we've successfully deployed our stack. When we try to access our dashboard, we find there's a delay between starting up the stack and the dashboard becoming available. And we have to log in again, admin@opencti.io with our password. We can now see we're starting to get data being ingested. And we'll leave this for a moment while it ingests its new data. We've now got a reasonable amount of data ingested, and it's still coming in. If we scroll down, we can see various dashboards showing key malware reports, activity by country, and a list of reports. Let's have a look at the Kaiji Linux malware. And this is a threat report from Alien Vault. It's based on the Golang technology and is Chinese sourced. Let's have a look at the Lazarus Group, a North Korean state-sponsored cyber threat group, and this is a report from MITRE Corporation. There's a lot to explore here, and more connectors that you can add, especially if you have access to your enterprise accounts with vendors such as CrowdStrike and Kaspersky. Let's leave this here, and you can have fun exploring this yourself. I've cloned the Kali Purple template and made a new server called Taxi. We're on it now, so let's install OpenTaxi. It's a Python tool, so we can install it directly with pip3. If we don't have that installed, we can install that with the command sudo apt install python 3-pip. Okay, I've got that installed already. We'll now install OpenTaxi and also a system called Gunicorn, as this is used to run the server. We do that with pip3 sudo pip3 install OpenTaxi Gunicorn. And again, I have those already installed. By default, OpenTaxi goes into our user local bin folder. And if we have a look at user local bin, we can see there's a lot of tools that OpenTaxi provides us to use. I've set up a folder for OpenTaxi in the home directory and called it OpenTaxi. So we'll go into that, and we can obtain a default configuration file from the GitHub site, which I've done already. I've modified the secret value in it and the folder name, but otherwise it's pretty standard. Let's take a look at it. And we can see that the domain localhost 9000 is the main IP and port for the system. And we've created a secret called Enterprising Mandeville. We've retained support basic auth to keep the default user ID and password authentication. And we're using an SQLite database. Our SQLite database will be created in our OpenTaxi folder. Okay, let's close that. Now we need to specify the structure of our collections, services, and user accounts. OpenTaxi provides a default example for this, but we'll use a different one. We'll use a critical infrastructure focused configuration. And let's take a look at that. It's in a file called threat.yaml, which is in your exercise folder. We can see that we have a government critical infrastructure protection inbox and a series of wholesale and retail network and power companies. In the discovery section, we advertise these services. And we have a collection management section and one collection, which is the critical infrastructure threat collection. At the bottom of the file, we have our user accounts. Okay, let's close this. We can use this specification file to create our databases. The first thing we need to do is define the location of our taxi.yaml file, which we'll do with the command export OpenTaxi config is home Kali OpenTaxi taxi.yaml. And we can then create the databases from the threat.yaml file with the command user local bin OpenTaxi sync data threat.yaml. And now if we have a look in our folder, we'll find we have two additional database files, auth.db and data.db. Let's make OpenTaxi a service. For this, we'll need to set up the Gunicorn call in a bash script, which we'll call taxi.sh. And we'll specify the IP address as 0000 so that we can access this both locally and externally. Nano taxi.sh. And again, we'll put our export open taxi config equals /home /Kali /open taxi /taxi.yaml, and we'll run Gunicorn to start up our Python script as a service, opentaxi.http://app, and we'll bind it to 0.0.0.0:9000, and we'll put the config space Python open taxi.http. Okay, that's all we need to do, and we need to gmod plus x that, and create a service file description for it. Sudo nano / etc / systemd / system / taxi.service unit description equals open taxi service after equals network.target service type equals simple, user equals root, user equals Kali, group equals Kali, exec start equals /bin/bash, and we're going to execute /home /Kali /opentaxi /taxi.sh and install wanted by equals multi.user multi-user.target. Okay, and we'll sudo system control enable the taxi service and start it up now. Okay, we have a running OpenTaxi server. We haven't defined any data formats. OpenTaxi moves messages, but it doesn't care what's in them. It's the client interface to OpenTaxi, which is content aware. We're on the Velociraptor portal and we have 3 connected clients. Let's select the drop-down for Clients and Show All and select Web01. This presents the basic profile of the server. At the top right, we can click on Shell, and we have a bash session opened. Let's check what processes are running by typing ps aux and then launch. And that's currently processing and has completed. This sends the command across to the server and returns the results, which we can see by clicking the Load Output icon. And if we scroll down, we can see all the processes running on the host, including, as we scroll down, the Velociraptor agent. By having the Velociraptor agent installed, we have command line access from the central portal in order to investigate our client servers and workstations. The true power of Velociraptor is that it can query thousands of endpoints as easily as it can query a single host. We're certainly not going to see this power with just 3 clients, but let's see what we can do with it. Velociraptor has its own VQL query language, which we can use to search our hosts, and it comes with a number of pre-existing queries which we can use. If we click the menu hamburger and the hunt manager, and we press the plus symbol to start a new hunt, we'll give this a description of checking SSH logins, and we'll leave the default as run everywhere. We'll check the Start Hunt Immediately box, and this will run the hunt as soon as we launch it. If we don't check this, we can prepare our hunts and then run them when we're ready to do that. We can see that all 3 of our clients are affected. We can now move on to select artifacts. We've got 3 major categories of pre-existing searches here: generic, Linux, and Windows. For this query, we'll scroll down and select Linux syslog SSH login. This won't pick up any Windows events, but that's okay. At the right, we have the explanation of what this artifact is, including the actual query. That's all we need to do. We can skip over the remaining actions and go straight to launch. Because we elect to start immediately, we can see the hourglass symbol by our hunt. If we click on the hunt name, we get the current status in the panel below. The clients are scheduled and then run. The hunt remains in a running state until it reaches its expiry time. This means that any new clients or clients which are not currently connected will be included in the hunt if they connect prior to the expiry time. Okay, we're now showing 3 finished. We can click the Clients tab to get the links to the individual clients. Let's firstly select the Windows Server apps02 by clicking its Flow ID. As expected, we have none. Let's go back and select app01. We can see from the logs that there's been more activity, and when we select the Results tab, we find a list of the SSH logins that have been recorded in the server's logs. This is showing both successful and fail logs. Similarly, for Web01, this is showing both successful and failed logs, and we can see a lot of failed logs from Actar, which indicates that the system has been under attack. Okay, let's close this. Let's now select Notebook. We can see we've got the heading and some of our first client results. If we click on the heading and then click the edit icon, we see this notebook in Markdown form. The results that we see in the table are produced by the query we can see, which has a limit of 50 lines. Let's change that to 5,000. Save the Markdown and recalculate. Now we have a lot more results showing. Just as we change the lines, we can adjust the query to filter out data we might or might not want, or to group results in some way. When we're done, we can download the notepad in JSON or in CSV form for further analysis or reporting. We can also run queries manually. From the home screen, let's select Notebooks. We'll add a new notebook and call it My Hunt. And we'll add a short description. This is a manual hunt for the gym exploit. And we'll submit that. We can now select it, click on the title, and press Edit. We'll make sure we're set to VQL at the right-hand drop-down, and then enter a title and a VQL script. Hunting Kamehameha. And we'll select star from globs equal /var/www/*kamehameha.php. Okay, and we'll save this. It automatically recalculates. This has been a very quick introduction to Velociraptor, and it hasn't really started to examine the power of VQL. However, having installed Velociraptor on your system and learned how to get around it, you've got a great foundation to build on. As well as running commands, we can browse the file system by selecting the VFS control. We've got 3 options listed on the left: Auto, NTFS, and Registry. We'll open the Auto folder, and the controls at the top right become active. We can now click on the folder icon to refresh the listing. We then get the content showing in the right-hand panel, and we can close and open the left-hand panel to see the contents there also. As we select a folder on the left, say Home, we need to refresh the folder contents on the right-hand side. Similarly, we can open and close /Home on the left to refresh the contents there. We can select Kali and again refresh the folder. Of course, refreshing each folder manually is time-consuming, so we can do it recursively. Let's select our var folder, and instead of clicking the leftmost folder icon, we'll click the one next to it. This now refreshes the folder and all its subfolders. When we open it in the left-hand panel, we can go down to a subfolder, say var log, and we can see that it's been enumerated. It's worth remembering that any changes made to the file system on the server won't automatically show up in Velociraptor. We do have to do refreshes to get the current state. We can work not only at the directory level, but at the individual file level to inspect contents. I've selected the access log1 file in var log nginx, and we see the file directory data in the lower left-hand panel, together with an option to collect the file. Let's now click Collect from the client. Once we do that, then the file hash appears in the right-hand panel, together with a preview link. If we click on the preview link, then the file inspection window pops up and we can see the beginning of the file. We'll close this, and in the lower left-hand panel we have a download icon. We can click on this to download the file. Another useful tool to have in Kali Purple's inventory of operational security servers is the Velociraptor Incident Response Server. This is another agent-based system, and its role is to investigate incidents through running on-host investigations across a fleet of servers. I've prepared the VRaptor virtual machine from our Kali Purple template. The first thing we'll do is create a folder for Velociraptor. We'll call it VRaptor. Make dir VRaptor and change directory into it. We'll download the current Velociraptor executable, version 0.6.9. wget https github.com velocidex Velociraptor releases download version 0.6.9 Velociraptor dash v 0.6.9 dash Linux dash AMD 64, and we'll have a slightly shorter name for it, VRaptor. Okay, we'll now make this executable. Chmod plus X VRaptor. We'll switch to root for the installation process. Sudo su Kali. We'll start the installation by running Velociraptor to create a configuration file. VRaptor config generate, and we want to store that in /etc /velociraptor.config.yaml. Okay, we need to update the configuration with our IP addresses. And we do that with nano /etc /velociraptor.config.yaml. There's 4 places to change the IP address. The server URL 192.168.1.117 is our IP address. The API 192.168.1.117. The GUI 92.168.1.117. And the monitoring host 192.168.1.117. Okay. We'll also add a line to allow self-signed certificates when we use HTTPS. Below the server URL, we'll say use self-signed SSL. True. Okay, we can save this now. We can now create our admin user, which we'll call Cybex. vraptor --config /etc/ velociraptor.config.yaml user add Cybex --role administrator. And for the password, we'll also use Cybex. So we've installed Velociraptor. So now let's start it up. We do that with the front end command. /vraptor --config etc. velociraptor config.yaml front end -v. Okay, this has started and we can see that we've got various services available, including the API and the Prometheus monitoring server. The front end can be accessed through port 8889. Let's go there. https 192.168.1.117.8889. And we'll take advance, accept the risk and continue, and use our credentials to log in. And we have the main portal showing the common tasks we can run using Velociraptor. Before we move on to connecting agents into the server, let's set up Velociraptor as a service. To do this, we'll create a service definition file. sudo nano /etc/ /systemd/system /vraptor.service. And as we've done it before, we'll put the unit description equals Velociraptor IR, after equals network.target, the service itself, type equals simple, user is root, exec start equals /home/Kali /vraptor -config /etc/ velociraptor.config.yaml front end -v. Just use the same command. And install wanted by equals multi-user.target. Okay, we can save that. And we can then enable that. Sudo system control enable vraptor. Now we have a Velociraptor server, we'll install the Velociraptor agent on the host we want to have connected. In order to do that, we need to generate a client configuration file. We're in a root session in our vraptor server, and so we can issue the command vraptor --config etc. velociraptor.config.yaml, and our command is config client, and we want to save that in a file called client.config.yaml. We can now open a web server so that we can download the executable and configuration files to our clients. We'll have to switch off Velociraptor to do this if it's running. System control, stop vraptor, and -3 -m http.server. We're on our Web01 client, so let's create the vraptor folder, make the vraptor and cd vraptor. And we can now copy the binary and configuration files across. wget http 192.168.1.117 port 8000, and we can copy vraptor, and we can copy client.config.yaml. Okay, let's set up the client to automatically start on reboot, as we did for the server, but using the client start command. nano/etc/system/system/vraptor.service. We'll use sudo for that. And unit description equals velociraptor agent. After equals network target service. Type is simple. User is root. And for our exec start, we want home Kali vraptor --config, and that's going to be /home/Kali/vraptor/client.config.yaml. And now we're going to start not the front end but the client -v. Install wanted by equals multi-user.target, and we can save that. Okay, just before we start the vraptor agent, let's go back to our vraptor server. We'll close down the HTTP server and we'll start up vraptor. Okay, we're at the main screen from vraptor. So let's just go to the home, and we can see we currently have no connected clients. We can now start the Velociraptor agent, and we'll need to start it as root. First of all, we'll sudo chmod +x vraptor to make it executable, and then sudo system control enable vraptor and start it up now. Okay, and we refresh, and we now find that we've got one connected client. We can install the Velociraptor agent in app01 in the same way as we did for web01. Why don't you take a few moments to do this before proceeding to the next video? Remember that app01 is a Ubuntu host, so your home folder is /home/Ubuntu, not /home/Kali. Installing Velociraptor on Windows is very simple, involving just copying over the client configuration file and downloading and installing Velociraptor from the Velocidex page shown here. I've downloaded the MSI file from the Velocidex website, so we can double-click to install it. The installation is very quick, and we'll find Velociraptor under Program Files, Velociraptor. This configuration file is a placeholder, and I've copied ours over from the server as we did before. And if I go to Users, Administrator, so we take our client.config.yaml file, which we can copy from our administrators folder, and replace the client.config.yaml in Program Files. Okay, we can now open a command shell and set up Velociraptor as a service. cd/program files/ Velociraptor, and run Velociraptor --config client.config.yaml service install. And if we check our services files, and we can see Velociraptors installed and running, let's restart the service to activate our new configuration. And it takes a little while for the dashboard to catch up, but eventually we find that we have 3 current connections. And if we check the Search Clients drop-down and Show All, we find we've got App01, Web01 and App02 showing. In this course, you've learned about the Kali Purple workstation, as well as how to install and run a number of key open-source operational security systems. You've built a solid foundation from which you can progress towards gaining the Offensive Security Defense Analyst certification. Kali Purple is a new system and it's evolving rapidly, so I'll be adding more content to this course as time goes on. Remember to check the latest updates to this course so that you can keep up with the latest tools being added to Kali Purple. Cybersecurity as a whole continues to evolve, and there's always more to learn. I'd invite you to go to my LinkedIn Learning page and check out my other security courses. You'll find a number of cybersecurity courses on my page covering a wide range of topics from cybersecurity foundations through to specialist areas such as zero trust and ethical hacking. There's always new things to learn in the wider field of information and cybersecurity, so check out the full security segment of the LinkedIn library, where new courses are added regularly. You'll find courses on all aspects of security. Thanks again for joining me on this course, and I hope to see you again soon for more courses on cybersecurity.